I mean, I just
Lexi Casson is the head of data ethics at
I
NVIDIA should do something like this framework.
I don't say anything wrong.
Just don't say anything unethical.
That's a pretty big assumption,
Rich, we're good to
Ollie,
go.
that I'm always ethical.
Okay. Well, after that incredible presentation by my friend Patendi, I feel very small because we certainly haven't made as much progress. So my name is Rich Tong. I'm going to just, in an hour and a half, try to cover everything there is to know about artificial intelligence. So hold on to your hats. I just want to say at the outset that it's a very hard presentation to actually organize and get. So I've tried to do some of the highlights. Also, as usual, the last few weeks I've completely updated everything I had before Christmas, so I had to change a bunch of slides. There will be a bit of a shameless, I don't want to say commercial, but we do these things with Paul because we believe in the value of understanding what's going to happen ahead, so we can build our products well. So we are a business applications company building business enterprise solutions. We're not going to go through our whole thing, but we do have 6 major customers right now. Hopefully we'll catch some break even this year, Paul. I'm hoping. And primarily what we do is we sell to other business partners who have that AI knowledge. As you saw in the previous presentation, I know some of you didn't. Lots in the knowledge and a lots in the ability to into something useful. Steve Suarez has been super vital in terms of helping us do that. Basically, everyone in the room has Paul, Harrell, and I see my friend back there. So what I'm going to do now is I've been using the slide deck for a year and a half now. I still feel like, say, what's all this then about AI? Because it is so complicated. So what I'd like to do is just remind everybody that we actually have a little YouTube group. We have a history thing. We also do a monthly deep dive, but this is really about the news and predictions. One change we're making all from last year is I'm updating this every week now. It's way too much trouble to try to go through a quarter worth of work. So I just want to give you a little bit of perspective. So this is my quick perspective slide. So in 1930, the world GDP was right here. We're right now at $80 trillion. So if you feel like the world has changed and you can't keep up, it really has. By the way, does anyone know? This dot is in the year 2000, right? We basically doubled our GDP in 25 years. So just to realize that is why it feels so impossible to keep up. That we have over, this is when Christ was born. How much progress we've made in the last 100 years. The other thing is that the time to adapt has shrunk dramatically. I always remind myself sitting here in England that it took 140 years for the spindle for sewing machines to be adopted. And this whole internet thing has happened in less than 5 years. And large language models essentially we're at month 18 right now. The second thing is this is a survey of actual usage of various large language models in large corporates. And the surprising thing I think about this is I expected ChatGPT to be 90% of the business. But in fact, there's a tremendous variation on what people are using. And you just heard that our colleagues over there are using Llama. We've used to use Llama heavily. Now we're using Qwen and we're on the DeepSeek. So you just realize that things are changing more than you can imagine. So paying attention to this stuff really makes a difference. This, by the way, is the final stats on 2024. So for the first time in history, we broke 10,000 CS papers for the year average last year. So this is a total number of CS papers ever published. And you can see we're at it literally an exponential rate. So things are happening much more quickly than ever. By the way, this has to take away most of the big tech guys have stopped publishing papers. So this is just the real open source community now. Who knows what's going on in those companies? And I think the big picture is, I don't know why my slide didn't look nice. Well, anyway, this is my favorite Paul slide. We started off here last year, and I think we're sort of here if I were to summarize enterprise customers. It's not as easy as doing a GPT-4 prompt, right? And what we're trying to do with the AI Hub is try to keep you along here. There's a little trough, but it's very depressing. I'll fix in the next slides. So because it's so hard to explain what's going on, I finally decided we should just layer the presentation from bottom to top. So first we're going to talk about the base models. Then we're going to talk about how they work internally. Then we're going to talk about how you train them. We're going to talk about this crazy prompting thing we just discussed, like how you program them, basically. We're talking about the thing called agents. We'll talk about hardware operations, and then there's customers way in the distance that have to get it home. I'm not going to ask you to read this, but you can read this at your leisure. So I went, when I worked at Microsoft, I always graded myself on how well I did. So these were the predictions from last year. And the checks are where we're pretty good. The yellows are where we were wrong. And then, fortunately, we didn't have any red ones this time. So starting from the bottom, the big prediction was that would be raining LLMs, which it definitely is. Second prediction is that OpenAI would catch up. But there was a big prediction that GPT-5, e.g. fully autonomous agents, would be here. Right? In fact, I just read a post from Sam that said he actually shipped it. He just didn't tell us. So I guess it arrived, we know. The second thing was the model internals were changed very dramatically. You're going to see a presentation about this, but when we started 2024, it was all about text. And now it is about images and video. And Dion, my colleague, is going to show you what you can do with real-time video production on your laptop. It's not a big H100 complex. This is a tiny machine that runs on your laptop. These are huge changes. Now, training was another interesting thing because it was clear the internet was going to be completely devoured. And Ilya, our Russian friends, can you ask about? Thank you. Predicted that we would, that data was the new oil, and we've run out. So everything has been focused on new ways to post-train, how to tune models. Healthcare is a good example we just heard about. We're doing the same thing in customer service, retail, and so forth, because the models have almost too much data. Right? Fine-tuning, I'm actually the most shocked by this. So the site called Hugging Face, if you don't use Hugging Face, you should. It's the open source model thing. The double rate, I just checked this again, Paul, the double rate, the number of open models is every 6 months. So we've got to 1.2 million open source models now. We're at 600,000 back in April. Right, so that just shows the amount of open source energy. And it's all based on the fact that because open source caught up, suddenly innovation can happen. So there is doubtlessly a tuned model for you. So
open source really means open weight. Most of this is retraining Llama in some kind. Of those 1.2 million, how many are just Llama
Most are Llama retrainings, yes. The first true open source models have now arrived. Tulu from actually our hometown of Seattle is one of the first truly open source models, which basically means, just to define it, you get the weights for free, but you don't know how it was trained, and you don't know the model structure. But Tulu is an example of we, by the way, use it extensively internally. That's fully open source. So content, model structure, and model weights. So one of our predictions, by the way, is that someone's going to ship a great true open source model. So I don't think we've seen the end of that story yet.
Well, get into it, but I mean, the question is who's going to pay the training costs for those people? Where are they getting their resources to train them? So we should come back to that.
We'll come back to that. But one of the big innovations, the reason I had to rewrite my deck, was the old days of it took $30 million to train a model has now collapsed to $5 million because of something called DeepSeek. So there's considerable speculation now. If you're in the $5 million range, something in the range of, not that we could pass a hat here, but you could pass a hat to some people to create an open source model that's a lot more like Linux. At 30 million a pop, it's pretty hard, but at 5 million a pop, it seems much more reasonable. And part of that is because people have become much smarter on training, and also for us hardware geeks, they just moved to floating point 16. Like literally, they just have the precision, and it had a dramatic improvement. So I think that we'll talk about predictions. I'm going to do those next.
So should I shorten video or not?
You should never shorten video. Like this.
Send a robot to get you.
That has lots more to do with account control and so forth. But as you know, these things take a long time to roll. The sixth layer is, I used to call it a large language model operating system. The term of art now is agents, and everything's an agent. We're going to dive into that. But basically, there was so much hype that we'd have full agentized systems, and that definitely didn't happen. There are experiments, and you can have agents completely out of control, but they're not really there yet. And then ML ops was forecast is basically going to be way harder to deploy than you think, and it is actually way harder to deploy than you think. And then the big forecast from here was that OpenAI's lead would shrink, deployments would be hard, and VCs would spend a lot of money. Those both turned out to be true. So maybe with great, I debated whether I should put this last or first, whether I should be laughed at or not. So, but here with the sort of certainty projections of red, meaning I'm not really sure, yellow maybe, to green I'm pretty sure. This is sort of our predictions from the bottom to the top. So in terms of out-of-the-box models, the reason I put this in red is Ilya and everyone else is promising this amazing change with GPT-5 and the next generation of models to be fully autonomous and so forth. So if you take them at their word, that's definitely going to happen. On the other hand, it's interesting that there's not as much general, I think, consensus on this point anymore. So, for instance, people that I listen to, like Andrew Ng, isn't saying this, right? Whereas last year, everyone was singing out of the same songbook. So I think there's some debate here about what's happening. For instance, Sam basically said, as I said, he said he already shipped it. It's already done. But anyone who uses these models on a day-to-day basis knows it's not quite done yet. And what they mean by done is a fully autonomous Skynet can do everything you want. I don't think. Okay, model internals. This is a bet here, but we're finding that speech as a sort of a native interface is really happening much faster than we think. So actually, we're going to show some demos of that where you can actually record a conversation, record a meeting like this, and then come up with, like, here are the things that happen in the business world and so forth. I was speaking with my colleague from SAP, and it's so easy to take text or anything, just turn it into something very natural. And speech is the natural language, right? It's the first natural language. We also think that real-time video processing is actually happening much faster. Dion's looking ahead for us, is going to cover some of that, but it's amazing what you can now produce with a few voice prompts. And what that means is you can take your sort of dull memo and turn it into a compelling video to send to your whole company. That's going to be a big deal. On the fine-tuning side, I think that what I would say, regardless of what happens here, whether true open weights or not, the cat's sort of out of the bag. People are fine-tuning like crazy.
You skipped over training.
Training. Okay, I'll talk about training. So, they're actually very related. So training used to be about pre-training and jamming everything in. Now it's all about post-training and how I do everything else behind it, because you essentially ingest the entire corpus. Most of the work in training is in the research world, which is how they can significantly reduce training by using synthetic data, right? Because there's not enough data. And so most of the models are just, and the rumor, by the way, is GPT-5 is actually being used to train GPT 4.5, that Anthropic's big models being used to train the small models, because in essence, the reason the performance advantage versus the cost is not worth it. So it's much better to take the smart sage and train the small one. So the training thing, we're sort of in that, what I would call the post-training heyday. E.g., pre-training was so easy and so obvious, and now what do you do to post-train things? No one really is sure about that. There's a lot of research on this, primarily focused, as I said, around synthetic, which is how can I train things? The most interesting thing here being, remember, large language models, when they read their response and your question at the same time, right? So every time you get a generation, you have to remember they've read the whole past. So if you can feed it a script that is how you want conversation to go, it'll get better, right? So that's one of the things to understand. That's when, if you've ever wondered why a lot of times you'll type in and it says, oh, excuse me, I didn't realize I made a mistake. It's because it's actually literally reading the text. Right. So when you generate, right? So just to explain this, I have a slide on this, but you say like, who is Taylor Swift, and it writes a bunch of stuff. The computer actually never reads that stuff until you type another prompt. Then it reads its response. It goes, oh, I didn't realize I said that. That's how they work. So the better the sequence you get, and the more natural it is, for instance, for patients or whatever, the better it is. And that's how you do. That's why you need synthetic. Okay, and then number 5, I guess I did put this here. There is this question of who needs 1 million B200s, right? So down here, if you say training has gotten easier, then you do wonder why the projections for needing, for instance, we have 100,000. I think that's the largest complex right now. 200,000.
100,000.
100,000 in Tennessee, right? Memphis, yeah, Memphis, Tennessee. And people are running around saying, "Well, we need 1 million of them if you just do the straight projection." But then on the other hand, if I tell you, "Well, the training days are over," then why do I need 1 million?
Not for inference time compute.
We're going to talk about that in a second, but this is the AI edge problem. So inference has gotten a lot easier on the edge. And so what you wonder is whether do I need all those H100s in the top when I can do local inference on these machines. We're going to show a bunch of benchmarks that basically shows that on the machine he's got right here, it's doing 185 tokens per second out without fancy hardware, without wafer scale, without H100s. It ships in this little machine. So there's a balance point that we may hit, which is basically I want to push as much inference to the edge as I can because it reduces cost. Small commercial, that's our path right now. We hope to get to zero backend infrastructure costs. Just roll out an app that just runs on a modern AI PC, and then it's just like regular software. It seems like in the next 1 or 2 turns of the crank that can happen.
Rich, how much do you see the digits box announced at
It's a
CES?
big deal. It's a huge deal. I mean, I can't tell you everything that I know, but let's just say it's the first of many people who are noticing that sticking RAM right on top of a high performance matrix processor, which they use fancy names, but it's basically matrix math accelerators, gives you on performance and inference. So there's
And back to Paul's question, how much does that cannibalize their data center sales? Because
this is the problem NVIDIA is going to have, right? The better they do there, the worse they do here. But there are many vendors, some of whom are our CTOs, who think that I'd much rather be on the edge, where in fact I don't have a single vendor problem, than be in the cloud where there's a single vendor problem. So that's one of the trade-offs right now. So to give you just that example, which we'll cover here, DeepSeek V3, which is the brand new one, it runs in an 8-way H200 well, but the tuned models appear to work very well in an M4 Max. So you're losing about 10 or 20% performance, but you're going from a gigantic machine to a machine that you can deploy and scale for. And for those of you who weren't in the lab cloud, I'm looking at Bill, this whole PC versus server thing has been happening for, I guess, as long as I've known you, for 35 years now. And there's always going to be this trade between these two. It does seem like everyone's noticed what Apple's been up to. And there's a lot of people saying, from Qualcomm to ARM, NVIDIA, saying we want to do the same thing. That's good for everyone in this room, by the way, right? Because it means the cost is about to really drop. Yes,
I gotta ask, NVIDIA launched the 5090 graphics card.
have a slide on this topic.
I believe that they deliberately crippled it by giving it just 32 gigabytes, so it wouldn't compete.
Well,
The M4 Max.
the M4 Mac has a big advantage that the matrix processor and the CPU eat out of the same RAM space, which allows you to be very efficient. And apparently, the next generation of x86 processors will do the same thing. So there's going to be a direct competition now between CPU and GPU. They're not going to be separate categories anymore.
By HBM producers.
Well, remember, if you do this, you don't need HBM. See, these guys don't use HBM, right? So that's a trick. Because they're using DDR. I'm sorry, nerdy. I apologize. They're not using DDR7, they're using DDR5.
It's also worth pointing out that if you actually look, the team that designed the M chip were acquired by Qualcomm, and ARM sued them over using the IP over it. So I think people have been onto this for quite a while in the hardware space. So it's very much coming out right now.
I think anyone who is like Ollie and the other groups are thinking about their next generation PC buy, this is a really interesting time. Because if you play your cards right, you can detether. Hope there are no NVIDIA people here. You can detether from a single vendor system, one that's multi-vendor, and it's great that Qualcomm is doing it, and ARM's doing it, and Apple's doing it, and now NVIDIA's doing it. I want to address your question. There is a real problem, if I were at NVIDIA, not that I am, between the fact you have the same core processor for the B200s, the RTX 5090s, and this new Daisy thing, and you got to balance carefully, right? Because if you give the RTX 5090 too much RAM, your direct competitor against your B200s, even though it's using much slower memory. And the product management there must be impossible, right? Because you got to go, I want to give the 5090, they give it 80 gigabytes, it's the same as the B200, B100. So everyone's going to go buy these things. Those of you who don't know, if you ever go on eBay, you'll find the biggest thing selling right now are what are called shucked RTX 4090s. So people who may look like me may be buying these consumer things, shucking out the RAM and everything, and putting them into another chassis to be run for inference because of the export controls. So you can see that trade-off happening all the time. And now they have to manage their MediaTek and digits thing, right? Because that is another competitor. If that's too good, you blow out your RTX 5090 sales. So it's not an easy job when you have this push. Okay, let's see. I think that we get to the operating system, and I just want to make one comment. The word agent has got to be the single most effing overused term of computer science.
The container.
At least containers had a real solid definition. This thing is, and I'll have a slide that covers it, agents means everything from a small piece of each model that has a very specific purpose, all the way up to autonomous Skynet. And literally people use the same term. So whenever someone says, I've got an agent system, you should say, what the hell do you mean?
How many?
How many, and is it on its own or whatever? By the way, just so you know, we are only doing small controllable agents. We're not doing it plans itself and you just, let it sit in a room for 2 days and it'll come up with whatever it comes with. Because that stuff is really hard. In ML ops, I think our big, that is those shops that are spending time on local cloud systems well. So if you're only cloud only and you're only on GPT-4, suddenly you're sort of cut yourself off from the infinite scalability that you get on the edge. If you only do the edge, you cut yourself off from some of the big things that are being done in the cloud. Like video generation is still very CPU intensive and you want to do that in the cloud. So this kind of hybrid cloud balance thing has reappeared once again. And I do think every time, I've done this maybe 3 or 4 times now. The harder you get here, the more the issues become the same no matter where you are. Right? It's a hybrid cloud balance. And then in customers, previous presentation, I completely agree with. Go hard to verticals, be deep, look for real annual recurring revenue, be part of the, improving the business, getting paid for by improving the business as opposed to just trying to make money. Right. The last thing I'll say is there's definitely a race to the top. E.g., OpenAI is sort of the race to lose at the top. And of course, once you get to the top as the incumbent, that's a huge advantage for them. So you can just feel the race to try to be the corporate standard. Anyway, so I just summarized the whole presentation in 10 minutes, as I was told to do in some class. Okay. Go backwards. Okay, so I'm just going to not talk too much about intuitions, but there's been a lot of debate, I think, in our industry as to what the hell AI is and what this whole thing is. And I show this slide every time, and I keep coming back to it, which is we're not yet at the artificial general intelligence singularity. It's not a stupid stochastic parrot. I was talking to Bill Becky yesterday. It's just a way to increase productivity by 10 to 100x in software. And you can make a lot of money and make a lot of people happy if you improve productivity. Okay, this is probably my largest section because it is by far the most dynamic, so I want to apologize. But it's hard not to talk about everything else unless you understand what's going on in the core model community. And it is really raining models. So this chart I've done over and over again, but for those of you who haven't seen it, this was 2023 when the race opened 18 months ago. This was the leader. So there's GPT-4, Claude, and GPT-3.5. The way this works is if you're 100 points difference, it's about a 60-40 win rate. So by the time you could drop down to 1,000, 100 points, that's a really significant difference. And the big question was, what was going to happen to this? So I did this wonderful slide at Christmas time, and this is the way it looked. And if you look at these top 20 vendors, this uses something called Arena. So these are random questions generated by random humans, as opposed to standard data sets, which cough, cough, people are not supposed to copy the answers, but maybe they do. And what you see here is that GPT-4 is up here at 1317, but look at all these other vendors, right? And it's interesting that if you look at this list, you see Llama 3.1405B, right, in contention. Right, this is the first time that you've had an open source model in contention. You see Yi Lightning, which is a Chinese model from Taifu, by the way, right here. And it's interesting to note that of the top 10 vendors who are represented here, there's multiple models from the same vendor, 2 are open and 4 are out ex-US, which is a big deal. Right? Now, here's the interesting thing. I had to change this because the whole stack changed. So DeepSeek V3 launched, and to the astonishment of everyone, even though it's got 1/5 the trading cost, it shouldn't be good. It's using crippled H800s.
DeepSeek.
DeepSeek is, okay, long story. It's a Chinese hedge fund that trained a model, and the thing was so good, they just released it as open weight model in December, was it 28th or something like that?
When you say they trained a model, did they write a whole model ground out?
Yes.
So it's more than just training a model. They have
It's not Llama.
they have their own proprietary
There's their own
software.
proprietary system. There's actually a good write-up on it that you can read about. It's like Quen, like DeepSeek. These are all bespoke models. It's not fine-tuned off of things. And to the astonishment of everybody, it's right here.
Sorry, Rich, but how are you feeling about the kind of Chineseification of that model? Because there's certain commentators are basically saying it's distorted, and it's basically carrying Chinese Communist Party.
So let me just cover that, the content thing. So sitting here, we as a company do not use it for actual content, right? So we're using it to build enterprise applications and so forth. So that leads us out of the battles as to whether or not when you type in certain things, is the model left, right, or balanced, right? So we love this thing because it actually is a great coding tool. It's great for this. Every model from every country is going to have this problem.
The amazing thing is that, when they started?
They started last year.
Well, that somebody starting last year without 100,000, B2 entities can be in the top 10 in that time frame.
That's why I had to write this. That's why I had to change this. I really did not, I really did not want to work on these slides, but I had to work on the slides because
How many parameters do they have?
670 billion.
Yeah, but it's only certain number of.
So they have some B200 equivalent or
No.
H100.
No, because we're going to cover this later. I get through the intro, which is they're using what's called a mixture of excerpts models.
Okay.
So they have 670 parameters, but only 38 billion are active at once. That is training and inference.
Yeah.
So that looks like
Rich,
the path to the future for a lot of these models is to go.
Mixture of experts.
Rich, this is Wasef. A quick question. I thought the big bottleneck,
What's that? We can't hear you. Can you speak up?
yes, I thought the big
Type your question
bottleneck.
in and Julian will ask it.
Type a question
All right,
into chat
I'll
because
do
we
that.
can't quite hear you.
Okay.
Very faint.
The speakers,
Keep going, Rich, and then we'll pick up.
So the other thing that was interesting is that going through this one popped up for the first time ever, which is Llama 3.370B. This model is literally 10 times smaller than any of the other models here, right? And this model, by the way, runs on my laptop.
So what Seth was asking, he thought the bottleneck was training time and fine tuning if you already have the data set.
It looks like there's a bunch of different bottlenecks, but to summarize, their tricks were number one, they went to half precision. So their mixed FP16 system, and that significantly reduces the amount of RAM you need. Which basically reduces that. The second thing they did was they used a lot of tokens, but they used a much smaller complex. And that seems to have helped it. So they only use 2800 H800s, which are sort of the nerfed version of the H100. And then the third trick we think is that they're using both multi-headed attention and they're using multi-token prediction. Right. So basically, every fancy research paper ever written in 2024 was used in this model, and oh my God, it worked. So this company, by the way, has been spun out amazingly out of this hedge fund, is now an independent company, and they're off into the races. You can download this model, by the way. This is on Hugging Face. It's an open weight model. The impact of this is that we are now at 4 open models on the top list, and we are down to the point where one of these actually runs locally, right? So, and this model is the brand new Llama 3.370B. Yes, it's at the very bottom, but just remember, this is something that can run on that little DAISY, that little digits thing. It can run on a MacBook. It can presumably run on Intel's next hardware. So it's actually very, very exciting to get that stage. I just wanted to make this comment because this is super confusing. You know, there is a model for every occasion. This chart, which we've shown a lot, is like the size of models. But I thought this thing from Nexus Flow, and Nexus Flow is a good example of a company that took Quen and then tuned it, and they had a good explanation of what all this tuning stuff is about, because you can tune models differently. And that's why a lot of times you'll see like a model is called DeepSeek Chat or DeepSeek Coder, because the things you feed it, it basically changes performance. Now, in a big model, before it doesn't matter, trillion parameters, all of them are in there. When you've got a small model, you really want to do this kind of tuning. One of the things we do at T&E a lot with Paul is, well, we need to use the agent model now. We need to use the code model now. We need to use the chat model now, because in essence, we're doing sort of a poor man mixture of experts thing. Right? Because normally you'd have all of these things piled into one, but it turns out the thing that my Patendi friend said is really accurate. Focus wins in these things. You don't want it to be all over the place. You want it to be very focused. So this shows they actually ship 2 models, both of which are state of the art. This is Nexus Flow. By the way, Nexus Flow is 10 people in Palo Alto, so you know how big this company is. And they train it, one just to do agentic work, which is basically mean doing planning, and another one just to be good at chat. So that's the new state, is there really is an LLM for every occasion and every. I feel like I'm selling a wedding dress or something. Every occasion, you can use it anytime you want. The second thing is that when you build these models, there's been, I can't even tell you the price crash. It is stunning, right? So as I said, DeepSeek also blew the doors out of pricing. So there had been a pricing ceiling or pricing floor around the OpenAI model. So the OpenAI models were at X, and everyone was plus or minus X. So DeepSeek had launched, and they're 27 cents per million tokens, which is essentially 10x GPT-4o, right? So this caused, by the way, on the internet, this consternation. And the reason, of course, is it's a smaller model. You can actually run it in a much smaller machine. And so they've basically been price bombing like crazy. So the price differences have been changing because actually OpenAI has been cutting their prices. But you can see there has been some speculation that the only people who are ever going to make money on this is NVIDIA. Because the price just keeps dropping and you still got to pay your B200 bill. So what happens? I do want to talk a little bit about this model to explain it, as Paul was asking. So it really does have everything but the kitchen sink. It has multi-headed latent attention, which basically means much smarter about what the right phrases are. It does multi-token prediction, so it doesn't just do one token at a time. It actually does 10 or 20 tokens at a time. And it does actually what's called speculative decoding, which basically means there's a little large language model that's talking, and the big model comes in and says, are you right? So it actually go ahead, and if it's right, then it's basically run a much faster decode. The result is that you can get about 67 tokens per second on this kind of complex, right? These are the stats on its training: 2.7 million H800 hours versus 30.8 million GPU hours for Llama 3. That's just a stunning difference in terms of training time. Also interesting that they do significant post-training, but it's only about 5% of the total work, which basically says that now this model is out, you're going to see a lot of fine-tunings of this DeepSeek thing. Questions?
Clearly, the DeepSeek team are craft. How are they that much better?
Well, I think you are. I mean, every time I see this, as soon as you democratize this stuff, I'd like to think that people always hire the best people and they only live in Silicon Valley, but the truth is there are lots of smart people everywhere. I wouldn't be surprised to see the next big breakthrough in Eastern Europe, for instance. You just need to have enough H100s to be able to do something. This is the model explosion thing I was talking about. These are the Hugging Face numbers that have been recorded. By the way, adding another 100,000 models over Christmas time was actually, to me, pretty impressive. This is Open Router, and what the Open Router is actually a good way to look at what people are actually using. So this is actually today, these are the total tokens pushed through this routing system. There's a lot of Sonnet.
Just explain quickly what Open Router is.
Open Router is a system where you can actually send a query to it, and you can find out what the cheapest LLM provider is in the world, and then it'll connect you to it. And we literally save like 10x. Because someone will run a promotion for, a 405B model, and it goes to free, and then you can just connect to it and then use it. So basically, it's an easy way to have one interface that connects you to everything. It's been super effective for us. But they also give you a view on what community's using. So this is actually the stats from today as to how many billions of tokens were pushed through the various systems. It's interesting to note that since many corporate customers are with OpenAI, they don't use the system. So you see a lot of Anthropic. That's probably number one. You know, the community knows this model is 13 days old and is at number 5 in terms of total models used. So this is one of the things that I think is very important for every enterprise. Being nimble about this is really, really important. It's where all the advantage comes from. And part of our reason we're here is so that we can worry about this stuff so you don't have to. It is complicated.
And to address Chris's question from before, I think we look back to the 40s and 50s, we saw America kind of its superior production values pushing its culture through Hollywood. We're just going to see a similar thing with models. Everyone's going to push their own culture through their models, and whoever's got the best performing one is going to make the most impact.
Yeah. But I hear there's going to be a lot of UK ones soon. Okay. But the last thing I want to comment is that tuning also matters. So this is actually pulled from today. Quen, which is a model from Alibaba, it scores 39 base points on these surveys. That model's been out for about 3 months, and this is the model tuning that people have been doing on it. And essentially, they increased the performance of this by a factor of 20%. Right? So it's gone from Newsbank Homer, one of my favorite people, it's got to a 47% average. This is again the what should I say? The democratization of the internet is so great, right? Whoever this person is a genius.
So what has that person actually been doing?
He has taken a bunch of these benchmarks, fed it some new data, and then essentially retuned the last layers.
In the
Quen model.
Quen model.
Yeah. So what all these people are doing is they're saying, for a specific use case, I want to do this. It turns out a lot of these models are, amazingly, Paul, some of these models may be rushed to production.
I'm shocked.
I know that never happened whenever you were in charge. So I think there's a lot of easy winnings that this is almost like Quen 2.51, the things you should have fixed, and they pick up next time. So this makes life even more complicated. You can use an open source model, can change, and then you have to go look at the tunings that are being done here. I also want to comment on the quality shift in local. So what you see here on the left, we have a smoke test for our local system. So they do all of our things. You'll see it in a second. And we ran on the cloud last year, and we started to move to local. So between late 2023 and mid 2024, we dutifully went to every model that came out. Mistral in September 23, it failed. Falcon 13V, no output generated. Falcon 3, this is basically an inventory test. So we feed it a bunch of inventory, see if it comes out with the right results. 5.3 from Microsoft failed. Llama 2, 7B failed. Llama, this is not a great thing. Something happened in this third quarter because this is the first time that Llama 3.211B was the first one that passed our local test. Right, and it's 2.5, the original one, 14B passed. Tulu, which is the full open source model, passed November 2024. Falcon 3 shipped and it passed. Granite's from IBM, it passed. 5.3 just passed. So basically what we're finding is these models are amazing at reasoning, even at very small sizes.
Have they kind of game the system or they really passed objective?
I think they really passed because this is a corpus that we have. It's not in the open. So this is our own specific test from our first customer. We took the prompts, we ran it through. I would find it hard to believe that they ran a test that did it just because these all failed. I think what I think this means is people are spending a lot more time on logic. This is good for my Batende friends. They're spending a lot more time on logic than they are on content. So it still knows who Taylor Swift is, but clearly a lot more tuning is going into logic and reasoning than ever before. But we actually had to extend the test. The first test was just an inventory test. We had to actually extend it to actually do financial analysis. So it's a sales thing. You have to actually ask it what are gross margins and so forth. So we keep on improving, but the quality shift is very pronounced. Okay, this is an eye chart, and I want to thank Julian and Dion and I don't even know he's on.
Yes.
Is Wissam on? Thank you, Wissam. These aren't real-life benchmarks of local performance. Now, let me just go through the columns. So these are M1 Max. By the way, it's the same processor on the iPad and the Mini, an M2 MacBook Air, Pro and Mini, an M3 Max, 120 gigabytes, an M4 Max, and so forth. The reason I put this first column here is this shows why you should never pay attention to benchmarks. So there's this thing called Geekbench AI, which they're so excited about giving. Turns out, if you read it, Geekbench AI has no large language models in it. It also only runs for 2 minutes in memory. So essentially, it doesn't test anything, right? It's basically testing how fast does the matrix multiply in these systems. And the numbers are astounding, right? 15,000 foo bars to 25 to 33 to 49,000. So the performance steps have been utterly remarkable. But again, you're not really testing the full system. So these are real-life benchmarks. So this is Llama 3.2 3B, so it's a small model. This is Tulu, the open source one. This is Quen, which we just talked about. And this is the one that is today winning. This is one of the top models in the world. So just to take this M14 Max, the way to read this is these systems are highly tuned. So the first number is when you first run it. You have to load it into memory. You have to load the context in. The second is sort of the hot load. This is really important on performance. The way to think about this is humans read at 6 tokens per second, right? So the reason you need 85 tokens, this by the way, is 85 tokens per second read and 51 tokens per second written. That's important because if you have 10 agents running, right, you've got to do this like 10 times. So what this means is I could run 10 agents inside, do 10 runs, and still meet my 6 tokens per second customer requirement. Does that make sense? So if I have to get 6 tokens out per second and I run at 60 tokens per second, I can run 8 to 10 models. Right, and you
assuming they all fit into memory.
Yes, assuming that in the memory sizes here, I should have written these down. This is 2.5 gigabytes. This is about 6. This is about 40, and this is about 48 gigabytes.
So the two constraints you're operating is how much memory I have and how big a model can I run in order to, in aggregate, generate 6 tokens per second.
Correct.
That's really the measure.
That's the measure. And what you want to do, Paul, is you want to get as many of these down here as you can, right? The second thing, which we won't have time to talk about, is you can actually, there's something called LoRa tuning. So you actually can take a model, customize it with just 200 or 300 megabytes. So you can have 10 different agents. In essence, you take up to 3 gigabytes here, but you only need another gigabyte for the personalities. That's the other trick. But you can see that with caching, it almost doubles in performance, right? It goes from 85 and 51 to 195 and 85. And this is a 4-year-old machine. And then with Tulu, you're at 278 read, 35 tokens per second out. One of the implications of this is if you've got 100,000 token, like an 80,000 document, it can take you 2 or 3 minutes just to load it into memory. So you got to be really careful what you load into memory and what you won't load into memory. We did this because this is just a bog standard M2 MacBook Pro 3 years ago that cost $1,200. Yeah. So even this machine can run Llama 3.2B very acceptably, 53 tokens, 13 tokens per second out. It can sort of crawl along with Tulu because the memory. It's all about memory. The memory bandwidth is about half. It's only about 200 gigabytes per second. So that's why you see it bogging down. Wisdom's machine, which I think was way highly tuned because it's faster than my input. That it actually does very well. So Llama is running at 491 seconds tokens in, 99 tokens per second out. And this is the first model that can actually run the state-of-the-art model at 112 tokens in, 7 tokens per second out. So not really acceptable yet. But we're also finding, there are very few cases where you really need this state-of-the-art performance. So we're primarily focused on this side. Now, just to go through the last one, which would be the competitor for digits. So this is the M4 Max, 128 gigabytes, which may be owned by some people in this room. And this is running at 1,000 tokens read, 127 tokens per second out, which is, to me, utterly astounding.
Did they announce what the cost of the digit machine is going to be?
They said starting at $3,000.
But for 128 gig, did they announce?
Oh, jeez. Oh, jeez. Oh.
It is 128 G of memory, and the starting at 3,000 is based on its spindle, more or less, for us old guys, right? It's the storage, not the RAM.
The solid state storage.
The storage, yeah. There we go. Sorry.
The SSD storage there.
Right. I do think that they are.
So they're competitive.
Oh yeah, they're very competitive. Well, it depends a lot. We'll talk about it. Depends a lot on what their memory bandwidth is. They didn't announce any specs. So, this machine, for instance, this is a 700 gigabyte per second RAM interface.
It's very fast.
It's very fast. And so if they're at 400, they won't be that competitive. So there's a lot of speculation as to what that interface would be. It actually takes a lot of work to make this that fast. I would also comment that the so-called M4 Ultra should be about double this in spec too, because it's 2 lashed together. So they expect about 1.2 terabytes per second. I can't even believe I'm using this number. RAM in. So what this is showing you is that we're getting quickly to the point where you can actually run this stuff locally. For all the you nerds out there, there's a lot of deep, like how this benchmark is run, the warm cache things. No, it's true. Okay, I want to talk a little bit about the LM internals. That was a long section because there's so much changed. We'll go a little bit faster here. But just to remind everybody, the way these models work is there's an embedding layer, then there's a context buffer, then there's attention, which basically tells you what to pay attention here, and then there's the architecture and the weights. And every one of these things has gone through a lot of evolution. So the interesting thing about this is that 18 months ago, you may not remember, GPT-3 had a context window of 4K tokens, which is about 3,000 words. Now 128,000 tokens is considered normal. And we're getting close to the big models running at 1 million tokens. Paul, just because you're going to ask this, it does have a big impact on RAM usage, though. So one of the tricks that are being used, you can also quantize the so-called key value cache and so forth. So in the real world, what we're seeing is there's a lot of interest in RAG for this reason, because you need to put the right things into context. It looks like for most of these models, once it's in context, it does very, very well. The key thing is what to put in there and pick the right things. You may have heard of this term graph RAG, which is sort of the latest term of art. It's a very simple idea that comes from, I think, the 70s or something, which is, Ollie is related to Julian, but your names aren't lexically similar, so I need to tie in a bow at the top that you're friends. And so these graph RAG things, when you read it, I feel like I'm reading a paper from the 80s about databases, because that's what it is. It's basically a way to pick the right things out correctly. There's a lot of use of so-called hybrid RAG, which is basically you split the model and you have re-ranking and so forth. I don't have time to show you the benchmark, but the RAG performance on these local machines is astonishing. And last thing is the vector databases have become highly commoditized. It's been interesting to see. That was supposed to be the big point. And I think my friend Julian said this was not going to be a big deal. And you're right. Basically, everyone uses some SQL add-on and et cetera, et cetera. Now, the main alternative that people are exploring is this idea that instead of having one model with million tokens, let's have a lot of small models that know something about what's going on, and you sort of weight them up. So instead of having a huge context buffer of 1 million, you have each model, each agent, if you will, specialized on something. So it knows a lot about stock markets in Asia, another one knows about commodities trading and so forth. So you have to feed the entire model. This makes some intuitive sense because at 1 million tokens, you do have a caching problem. You have a caching and attention problem. Like, how do you figure out what the right thing is.
Talking about state, the context window. Do you know what happened to the state space model, the Mamba?
Yeah, the state space models had a lot of promise. They have not yet shown that they are more
I'm not there yet.
It's like gallium arsenide versus silicon, right? Like every year, silicon was dead, and every year those guys are
So
just.
it's the one thing that is always going to be almost there. At least for now.
There's a lot of people with a lot of hope for state space models, but yet is not as performant. And I think everyone in the state space model is in consternation with DeepSeek. Personal opinion, they're like, "Oh my God, what do I do now?" This will continue to be true. Now, the other thing, as I said, there's a lot of work going on in terms of speed improvements. That is, I think, now that the sort of pre-training is done, there's a lot of work going down on fast inference. So this KV pre-cache actually is almost in every system right now. It's a very simple idea. If any sequence looks familiar, it remembers the keys and doesn't have to reprocess. All right. This will also be known as computer science has returned to business, because this is all anyone spent time on. The second big piece of attention has been on the embedding models themselves. It used to be everyone just used the OpenAI model. Turns out different embedding models can perform very differently. I was going to send you, but there's a bunch of tuning models just for medical terms, for instance. You want to have a totally different state space for medical terms, for financial, and so forth. We've been testing them internally. It actually does make quite a difference.
Yeah, I think that was one of the things that kind of everyone forgot when we're doing enterprise RAG, is that you have to embed with the right context. Otherwise, that's
so one of the things that we've done is, Julian talked about orchestration, but one of the things we're doing is letting you test 10, 50, or 100 of these techniques at one time, see what's better, and do that both in pre and at runtime. Because the problem that you have is you may have to dynamically switch these things because it's not correct. So as an example, Llama 3, 7B may fail. You have to have some way to back it up. It could also be that most of the time a 5.3 tiny model works, in which case you want to use that. So our system has all this harnessing to make sure you pick the right model at the right time. The speculative decoding thing, I think, is part of the future of the industry. A lot like other operating systems, just run a small model, try to figure out whether it's right, and as long as it's right, don't interrupt it, and just throw away the rest of the tokens. So in essence, run two models in tandem: a small model and a big model, and the big model basically does the judging for the small model. Okay, just talking about architecture and weights. So I think we already covered this, but mixture of experts has really become the research question. And so here's the problem. Something like Llama, for instance, which is called a dense model, you need to load all 405 billion parameters at once and calculate and run 405 billion parameters of calculation. But if you can put a gating network on the front and figure out I only need 38 billion parameters, now suddenly my performance improved a lot. And if I'm in a tiny RXT 5090, I can throw all these to RAM and leave this one in VRAM. So again, computer science is return, engineering's return. So there's been a lot of work on these dynamically chained gating models. Granite 3.1, which is from IBM, is actually a 3 billion parameters sparse model. So its actual weight is only like 700 megabytes. Right, so there's a lot of work going on there. I'd also comment that you can actually stack models and make your own MOE. This paper just came out last month, but you can actually take Llama 3, for instance, in Batende's case, tune it for different things and create a gigantic model and just turn things on automatically. So I think that could be the future of the industry, which is a lot of small reasoning-based models. Okay, Karpathy said, it's like an emerging operating system. We talk about all these inputs and outputs, and I'm here to report that, man, that is happening very quickly. So I'm going to have, we've already seen this extension of all these different kinds of content. The real change has been, what do we do with video and images and so forth? So I'm going to ask my friend Dion to come up. We've been running some experiments on this. So today, our system has a small agent system. It can read images, it can write images and so forth, but video is sort of the next thing. And he's been looking at how we can do this on just a local machine.
Got another 34 minutes.
Always on time,
Read.
by definition.
Perfect.
Okay, change.
Right, so as Rich said, thanks, Rich. We're
Looking
going to be
at,
covering image generation. I'll be talking about that a little bit. Let me just get my stuff out of the way. So we'll be covering diffusion models. I'm sure a lot of you are familiar with diffusion models, but I'm going to show you a tool that open source tool that's quite nice to play with is image generation, video generation. What I like about this tool is they decompose every single step of the image generation pipeline. So you can gain the intuition behind the intricacies of diffusion models and also the transformer-based models that we're going to touch on. So the tool is called Comfy UI. It has a little canvas and you can double click and add blocks. So let's start by creating an image. So typically these diffusion models are contained in a container type structure called the safe denser. And that basically just contains three main components. You only need three things for image generation. You need the model, then you need a clip model to steer the image generation in the right direction. And then since all of this is done in vector space, you need something to take it from vector space into image space to get pixels, and there you have it. So if we do that in real time, so I said we first load a model. So we're going to load some checkpoints. And what I have here is a model called DreamShaper V8. This is by a company called CVT AI or something. It's a pretty performant model. It's only 2 gigabytes in size. And as Rich also mentioned, I mean, a week from now, there's going to be a new kid on the block. So at least for this week, this is my favorite model. And the Flux one that I'll also touch on. Right, so now we have the model. Next step is we know that we need to steer this thing in the right direction. So we're going to add some clip blocks. The clip block contains the prompt. And in the stable diffusion case, a lot of these models have been trained with a positive and a negative prompt. So in the negative prompt, we put things like ugly, poor quality, NSFW, depending on what you don't want. And in the positive prompt, you put what you do want. But the prompt isn't the only thing. You also need to schedule this, because if we think about what stable diffusion is and how it works, just show you a little picture. This is just my note-taking Obsidian graph. So to remind everyone, when you're doing a stable diffusion model during training time, you feed the model images and the text description of the image. And every step you add more and more and more noise until you end up with a bunch of noise in the image. Now the model is trained. So during inference time, when you generate an image, you give it noise, you give it a prompt, and then it works back from the noise to give you your image. This is like crazy. This is how it works. So this is actually a visual representation of what a clip vector looks like if you just visually output it. And then this is visually what the latent space, what the noise looks like. So quite often folks refer to latent space. This just means that it's the images, all of the features, and we compress it down and we have a vector representation of it. And why we do that for performance reasons, because it means that we can effectively compression of around 64x on the images. So it just means training and inference time is way faster. And then once you've given it a prompt and it's generating a model and the prompt is steering it in the right direction, right before you convert it to pixels, you might find an image that looks like this. Now, this is actually something that makes sense, but from human eyes, it's completely, you can kind of see there's a mouth and 2 eyes, but I cheated because I know what the actual picture looks like. So if you convert this from the latent space.
This is a test. Sorry. On the hour.
It's 4 o'clock on a Friday, Monday.
If we convert this from the latent space to the image space, then we get our little kitty picture. So I will walk you through these very simple 3 steps in Comfy UI and show you how we do this. So text prompt. I like to just color the positive prompt with green, and then we can add a note for our Negative prompt. And we hook these things up. Now, next step would be the sampler, because we have to run through this for X amount of time. So it's interesting how this works. When you start with a noisy image and the prompt, the model actually predicts the amount of noise in the image. And then every time the predicted noise is subtracted from the original noise and incrementally until you eventually reach your picture. So this is why we're feeding it into our scheduler. There's different types of scheduling techniques you can use. I prefer Euler. There's also a DDM, a long acronym thing, but this is the most reliable one I found. We need a latent image. Empty latent image, we can stay with 512, that's fine. Hook up the latent image, we hook up the model. And remember, the final step is, this is all happening in latent space in the vector representation. So now we just need to decode it into pixels. So for that, we take a VAE. This is a variation autoencoder. It's the third piece of the puzzle. Clip, the model, and the variation autoencoder to get you in and out of the vector space. And then we can also just add an image preview. Oops. See what it looks like. And hook up. Zoom out. Hook up the autoencoder. And then we can give it some prompts. If I don't give it any prompts, it's just going to generate.
Dion, just the context of, is this the stuff you're doing? You need to create something for a customer, or is this the environment that the customer?
No,
Don't worry.
this is actually a.
No, we're going to make every office user do this.
I'll show you. That's a good question. This is actually a benchmarking tool and kind of a thing to rip apart these pipelines and figure out, gain a deeper intuition and see which models fail when and where. And then I'll show you a little pipeline I slapped together that uses an API call to this thing's engine to create a 60-second YouTube short.
So a customer needs a way to create a certain type of an image, and you guys are coming up with this entire framework by which it's going to do that, or is it like a prompt or something?
A prompt, yeah. It's a prompt.
But right now, you're saying got nothing to do with T&E. This is all Comfy UI.
Comfy UI.
Oh, we're in the middle of integrating this into the.
Yeah, but what we're seeing today is
Yeah, we're just showing that
just Comfy UI's world.
this is part of the education part of the class. Because here's what's happening in the open source community, and we're in the middle of integrating this too.
So giving it its prompts, let's just run it. Now it has to load the model. It has to do its whole things. Sampler is doing its sample, and that's pretty much the speed that you can get. This is an M3 Max. Now, it's not really firing up the GPU that much at all. I mean, it wasn't. Let's just do it again. This thing caches. Oh, it's on random. It's
What were the prompts you had there?
Oh, just a beautiful sunset in a park. This kind of gives you a speed of the local generation. A nice little trick that I like to pull.
What were the negative prompts you had?
Oh, negative prompt was just, in this case, poor quality. This model tends to generate nudes, so you should also add NSFW. And another thing, to really speed this up, just reduce the latent space. If you reduce the latent space down, do the generation, and then upscale it latent, it's way faster than trying to generate a 1080p image. So the second thing I want to show you, very interesting, fake, right? Is when it comes to conditioning, right? So remember, the clip vector steers the image to the desired result. So quite often, there's a lot of examples where you can't use a single prompt to generate an image because you get kind of bleeding between the things. I'll show you guys an example. Let me just reset my example here. So here we have two prompts. It's the same layout and structure as the previous example, exactly the same. We just have one additional prompt. And you see we have two positive prompts feeding into a conditioning average that will average the vector out and then feed it into the sampler. Okay. So if we set the conditioning average, like I've done, to 0, it should only allow this prompt. So a close-up of an anthropomorphic carrot wearing a full armor in an enchanted forest. Okay. So let's run that. So now we have our little carrot in the forest. So if we change carrot to panda, we will get Mr. Panda in the forest. But how do you combine carrot and panda? This might sound like a silly example, but a real use case is if you have a, let's say you want to generate images for clothing, fashion accessories. You have a model, you want to add fashion accessories to the model. What I've seen, if you try to do this in a single prompt, if you add a scarf, it will change the background to a winter scene, which is not what you want. But with this technique, you can kind of inject the scarf without the scarf bleeding any of the colors or the theme of the scarf into the rest of the image. So, and you'll see that in a second. If we change this, let's say to 0.3, which I've cheated, I know this is a like 0.5, I wasn't too satisfied with, but a 30%, this allows, say 30% of this prompt, 70% of that prompt. And you can clearly see there's like carroty vibes in this panda.
Okay.
So a lot of stuff, when it comes to stable diffusion, image generation, you work in latent space, and it's all around massaging the vectors to give you what you want. Now, this model has been trained on illustrations. A very nice one before we get to video. For more realistic scenes is the Flux model. So Flux by Black Forest Labs is capable of generating pretty realistic scenes in a pretty performant way. And this isn't a diffusion model. This uses a transformer. So the interesting thing here, during training, the transformer tries to understand the impact of noise on the structure data on the image. So instead of subsequently adding noise and working back, from the beginning it understands the impact of noise. And that's why this model typically converts in, I want to say 5 times faster than a diffusion model, 4 to 5 times faster. And a really, really impressive quality. Then the final thing is video. Now, we can attempt to do a live video generation. This is the same as image, just with a temporal component attached to it. So it's really important. In this example, we've generated 24 frames, so there's only a 1-second video. And the latent space is a cube with temporal information instead of just a...
Where's the temporal information here?
So that is captured during training time in the model. So what they do, you first train it as a normal image standard stable diffusion model. Then you train it on video. So after it understands how to make images, it understands how to string images together. So there's no inconsistencies between frames, smooth motion, all of that stuff.
What speed does it use? I mean, slow, fast? I mean, where do you specify?
Roughly 24 frames a second.
No, but in terms of the impact of the video, is it going slowly or fast? You specify that, or?
Oh, good question. I have seen examples, but I haven't done it myself, where you can.
Sorry, there's a couple of questions after.
Okay. Where you can influence it, it depends on what the guys did or what they trained it on.
Okay.
Yeah.
There's no pacing.
No.
The stable diffusion versus the other flux model that is, 5 to 10 times faster. What are the disadvantages?
Yeah, that's a good question. Flux uses a flow-based transformer. In my opinion, that's just the newer technology, because stable diffusion has been around for a while with small efficiencies made here and there. I think this is just maybe the next phase, the next new kid on the block.
Your expectation is it's just going to get as good and remain fast. Okay.
Yeah. Currently, my favorite model, the most capable one, is this flux model that I found.
The question from Stefan Line. Basically, his point: general image and video workflows are often dependent on iterative improvements.
And
Sorry,
Well,
it's
What's it? Do you want to just go into a bit more there?
Yes.
See if we can hear.
Can you guys hear me well?
Not well. There's a way of turning the volume up.
Should be
Yes.
a volume on that control.
Let me speak up as much as I can. So the graphic image work, creative work often depends on iterative improvement.
Sorry, hold it a moment. We're just trying to turn your voice up.
Okay, thank you.
Say something.
Yes, can you hear me now?
Now we can. Yes.
Okay, great. Thank
Perfect.
you. Thank you for accommodation, Julian. Dion, you know, graphic work often is iterative, meaning you have a concept, you change it, and then you say, okay, I love this part, I love that part, but change that other part, which I've found to be pretty much impossible with any generative video or image tool so far. And so how do you do that? How do you freeze something but work on something else, and you kind of really kind of feed into the process that almost everybody is using in the world, in the video world?
Okay, that's a good question. I can give you an example with the image stuff that we just did. So here we're just generating our images, like you said, Wasif. So I don't like this one. I generate the next image. If I like this one, the first step that you do is you can freeze the seed value, because at the moment it's set at randomize. So that's normally the first thing you can freeze it. And then the second thing you can do is once you like an image, you can add a little bit of noise and use that as the noise input image. It's a trick I've been playing with as a poor man's video generation scheme, where you can generate the first frame and then add noise and add that first frame as the latent image in the second frame, and so on and so forth. It's still cumbersome, Wasa, for sure. And then I can see why you will have trouble with that just generating off of something like OpenAI, because you don't have all of these lower level knobs to play with. For example, this CFG
Maybe
factor.
can you be more specific, Dion? Sorry, let's say, which is something that's very common. You say, I like the tree, make the lawn a little bit bigger, make the sunset a little richer.
Yes. So to add things, there's a technique called in-painting, where you, similar to what we've done with the carrot example, you can add, you can change the tree out to a different type of tree. You can add different things in the scene if you want. So I would look at in-painting for that, and also freezing the random seed once you have something you like. Does that answer it? Make sense?
Yes, thank you. So you introduce basically a different tool that essentially treats it as a pixel canvas and is working on a different part, or creating a different piece that gets added to it.
Yes, I think the trick here is to present the user with text prompts only, but abstract away the fact that you're really working in vector space. So instead of, like, we're all working with LLMs quite a lot, and there you only have the prompt. And you give the prompt to the LLM and you get your output. Here, there's a lot you can do in the vector space to do types of morphing like this, or to maybe replace the head of this animal with a different head. I don't have an working example like that, but it's definitely possible with State of the Future.
Okay.
Got it. Thank you.
The pipeline thing?
Sure.
Okay.
Just conscious.
Yeah, what's our time now?
Should we, because I want to show Paul's thing. Step down. I'll just step down. Okay, well, no. Good.
One last thing I can share with you is how we can put this together to create something sort of meaningful. Now we have a big push to run local, and of course you can generate little YouTube shorts using the Stable Diffusion video model. But if you want real fast turnaround time local, it makes more sense to generate images, because a lot of the marketing material, especially on shorts, you don't necessarily need video. As long as it's visual, that's more or less fine. So in this example, we can give it a prompt, the history of the London Stock Exchange. So what this system does, okay, it generates its own script. Of course, you can provide it with a script. But the first thing it does is it looks at the script, and then all of the music files we feed it. Some of this has been generated with AI, some of it is royalty free. Then It does an analysis on the music. So I look at tonality, I look at attack, I look at like the frequency components to kind of figure out which songs are more mellow, which are more lively and upbeat. And then the LLM decides based on the context of the script that it's received, it selects the most appropriate song. And then I'm using OpenAI's time captions functionality to then basically break up the entire script into timed captions. Because if you look at a short, you just want to get a couple of words in that video. And here it's actually running through a loop where it's self-correcting because the time captions didn't align properly on the edges of the frames. And now it's just pumping away, generating images. So for this video, for London Stock Exchange history, say this first image, it identified, I don't know why time travel, but historical journey, London Stock Exchanges. And you tell it, generate an image of this theme within the context of this larger story. And then it's going to run through its, run iteratively. You can see it's generating its images. And every time one of these lines are done, it's basically an image, and we will end up grabbing about 20 of them in a video. And then the final output looks like this. Let me just show you.
Worked.
Then this final touch applies a slight zoom effect because we're cheating. We're not creating videos, but images. And then there's obviously a talk track with it where we're using, at this stage, I think it's still OpenAI's voices. Although I can change that. There's some nice open source models available these days. That doesn't sound too robotic.
Thank you very much, Dion.
Perfect.
Well, as usual, I've got 5 more diamonds and it's we're gonna we do some pick and choose.
Yeah, go on.
Let's do some pick and choose. Okay, I kind of wanted to put it all together into one thing. Hopefully this will show it. So I kind of wanted to put it all together. So what you saw before, you saw Dion with some of the technology pieces. I just wanted to show you how it all gets put together into one thing. So what you're seeing here is our application, right? And the way this works is these are the top recommendations. We've talked, I know you have a board meeting to give. This is exactly what we started it for. The scenario here is we're working with the retail partner. They wanted to come up with the top 3 reasons, the top 3 recommendations for things they should do immediately. And it automatically generates an Outlook page, an Outlook email, a Word document, the Excel spreadsheets, and the drill down PowerPoints. And so the idea is we want to be able to get to the point where we could just take this whole thing, which is a web application, and just run it locally. So you're going to see for the first time, done yesterday, a project we call Orion, which is look, Ma, no hands. This is actually just a Mac app, and it actually inside of it includes the local language model system, the models, the runtime, and everything else. So we started last year with putting it all in the cloud. The question is, could we just load this as a regular Mac app? And I'm happy to say the guys did it. So if I, for instance, were to ask a question like, who is Taylor Swift? You're going to see 2 things going on. Does everyone see this thing popping up here? So this is the inference engine running. So what's happening is that it comes here, we then determine where we're going to get the data. What that says is, it's a large language model, to the chat history and push it to the LLM. It also made the decision there was enough locally that it could actually just process it locally, did not have to go upstairs. So one of the key ideas is,
Rich, what was it here? This is the first query went into an LLM that decided how it is going to be handled.
That's right.
So the first thing is you're going into your kind of orchestration.
Yeah. I just skipped 38 slides.
I know. So but the point is you've got a bunch of LLMs running here. The first of which is deciding which subsystem to direct the prompt. And in this case, it's directing it.
It said I can run this locally. I've got everything going. I can just feed it locally. If it's a more difficult prompt, it can then feed it offline.
What it directed to? I mean,
In this case, what it did is it said, I've got Llama 3.2
okay.
loaded. I'm just going to run it. It's already running. In another case, it may say, this is too big a query for me.
I'm gonna
run it.
Open AI or something.
The other thing that you'll find that we've done is this is all cached. So if we detect that it's the same query over and over again, we'll just short circuit the thing and just run it immediately. And we also do code generation. So if it's a regular thing we're doing all the time, we'll actually generate code and then you're just running code. So the idea, ironically, large language models, the biggest thing you want to do with large language models, don't use large language models, turn it into replicatable code, which is how we got to this sort of deterministic state. This particular application is running at a 97% reliability. We still have couple more percent to go.
Just to understand, if you had a query that says, show me our best seller.
Yep.
You would recognize that that's being done all the time, and you would just code up you get the LLM to code some Python code,
yeah.
And in future you would just the orchestrator at the front would just run that Python
and say the data's close enough, and the query's close enough. We're just going to run the code. This, by the way, for all of us enterprise people, very comforting to know. And Ollie, you can look and say 98% of my stuff is being run with replicatable code. I do have this 2% that is different, and then you can put it through a much higher check. So that our plan is that most of the time, and we're seeing most businesses, the questions are the same over and over again.
Yeah, well, that's what we see here in LSEG, and our AI models just system orchestrated.
Yeah. So the whole point is when you get a different one, then you can do something different. But if it's something that's the same, then you want to basically do things offline and so forth. Now, I want to apologize. It turns out that there is some interaction with the LSEG firewall. So about a quarter of the time, it doesn't push a query through because, so I'm going to just say, I'm just going to give you that little proviso. So we're going to try this. So what this is, so I just want to explain this. So these are the different personalities you can adopt. So this is the retail personality. So retail. This is one that knows how to go out onto the internet. This runs locally and so forth. So it's just a toy UI. It'll be much prettier.
And what is Maria?
Maria is our next customer. So we have 5 customers, and so we have a code name for our economic reports company. And I asked the developer to change the names. We didn't before the meeting, so I apologize for this.
So Rich, sorry, Maria is a persona of a customer?
Maria is the code name of a company.
Oh, I see. Got it.
Yeah. So I'm going to do something a little different. Thanks. In July. Now, obviously, that is not a query that's going to go very well locally. And so if I've been blocked by the LSEG firewall. I'm sorry, no worries. Anyway, what it would do is it would actually go outside, run the query on our local complex. So that's the idea. And I couldn't get my firewall. I couldn't get my VPN running internally, so I apologize for that. So anyway, that's sort of what these things are doing. The way that works is there is a studio behind it that does it, but we're finding these business rules are created by people. We're finding that it's really hard to get people to write these business rules. So I'd like to introduce Paul, who's going to show a system where you can actually record a meeting, figure out what the business rules are, and then inject it into the large language model.
I'm seated. I'm seated. How can you make it?
What is this then?
All right, looks like Paul is getting ready.
There you go.
Aliens. 13.
Any just afterwards.
We're going to go more depth. I just wanted to cover for the other folks, right?
Signally at pitch.
That's because God does not like you.
I changed that.
I know
over the long term.
You failed many years ago, Paul, so.
Jeez. Well, you're in good company.
I'm mirroring to a ZHD 60, which is.
It should be up there, yeah. It should be bucking.
Choice.
Still waiting.
We're working.
While we're sorting this out, Rich, do you want to go back go back to your 8-layer, your 8 predictions?
Yes.
And remind me what there's 5, 6, and 7 were.
5, 6, and 7 were. Not that I've memorized them myself.
Yeah.
5 was that there would be a.
Can you share it on the screen, please?
We just haven't got there yet. Just
We've got AV problems. We're doing the usual
Dancing.
show business thing of dancing.
5 was the hardware one, Paul, so it's the price crash. Number 6 was that the agent hype would continue, but there are some real things you can do with small agents getting to run. And then 7 had to do with MLOps, which is just balance between local and cloud.
So looking at the agent thing, which, as you said, is
sorry.
You said that the agent is a code name for the quote unquote what Andrew Yang, whatever it's called, the operating system behind LLMs. That's we haven't seen as yet any standardization framework for that.
It's been an absolute mess.
So it's still a mess. It's not like you can take LangChain today and do all of the things that you're wanting to do, that you, T&E, and Yoav are wanting to do with LangChain.
The problem is that
is it going in the right direction though?
Okay, so here's the deep issue. Almost all these frameworks are basically piles of Python code. So it's not this kind of scheduler that you and I might want to envision. There's like no API that says, please schedule me here. It's more like, these things are, just give you an example, the pipelines are actually hand constructed, right? So it goes def function, call this function, then call that function, then call this function. So number 1, it's almost impossible to debug because it's just code. Number 2, it's almost impossible to inspect to figure out what it's doing. And particularly the distributed ones, they get hung because most of these are blocking calls. So what can happen is you can actually call agent, and the thing blocks, and now you're stuck. So all of the normal things we're used to in operating systems, which is like reentrancy, abandonment, all those things are not there yet. There has been some movement. There's a protocol called MCP that Anthropic has done, but it's very low level. It's basically a call interface to call agents, but the actual scheduling is not really there yet. So one of the things we're doing is we're working on the real scheduling problems of you need to know when you have to abandon because the user's waiting for you, those kinds of things.
And you see the open source community starting to address that, or is there discussion over it? I mean, in some ways, Python is the worst possible environment to do this.
It's terrible. Yeah. So, in fact, we wrote our scheduler in TypeScript on Node. It's so much more performant. So I think this year, this is one of the predictions of 2025 is that this will be the year where we will get momentum towards one of these things because it's just too good. The tools are just too good.
To escape the Python ethos.
Part of the problem is the AI guys love Python, but this is the wrong tool for the job. And the systems guys would rather use Rust or a real programming language are sort of not in the ascendancy.
I think once you get the enterprise developer doing this, which they're not, as you can see by the state of all the big cloud providers. Once they're the ones doing this, then you find this repeatable infrastructure framework that works across different.
This is far away. Enterprise developers are not going to touch it in the next 2 years.
You made an interesting comment, which I think is sort of a new law that I'm going to adopt, which is you can measure the maturity of any space by looking at the maturity of what Amazon is offering. And you're saying that there's still a mess.
I would expect that by this point, you would find such a framework within Amazon because they're selling this, right? The people paying for it are coming to Amazon and saying, yeah, I want to build this ROG plus this plus that. And there's no such thing on Amazon.
This is SageMaker or Bedrock?
Yeah, Bedrock for sure, no, but even SageMaker.
Absolutely right. My personal bet is a little bit different, which I think, I'm not sure it's the enterprise guys, but there are a couple small groups that are doing good jobs, from the traditional Linux community. So I think bolt this traditional stuff onto the existing large language model stuff. So, right now the main runner, for instance, for large language models locally, something called Llama CPP, and all you would need to do is bolt that to a real framework. So that's I think there'll be two things. One is the enterprise guys will of course be there. Much more rapid could be the emergence of the real operating system guys looking at this like a scheduling problem, which is what it is. That shoe is yet to drop.
So this is Wasif here. Just question, since somebody mentioned Amazon on Bedrock, does anybody know exactly what's running on Bedrock? What are the most popular models and the kind of applications that are bootstrapping there?
Try to get it by mirror. It's still a collection that they keep expanding. It's just recent that they made it a little bit easier to choose different models. And you see that it's much easier doing it on Bedrock, and it's much more flexible SageMaker, but it's very nascent.
Yeah, and we just we've had problems running too. There are definitely reliability issues on that.
Zoom. Yeah, it just fails. It gives you.
It's the word for those of you who are doing it. It's so depressing. It just fails, just stops. You don't know what's happening. Yeah, and then you're sitting there wondering what happens. So that's one of the other reasons go local is you get a little more control. You actually know what's happening.
Has anybody looked at the Azure equivalent?
We don't have court.
We have. It doesn't seem like it's
better or any worse.
I mean, traditionally this is Amazon's sweet spot, right? It's making this thing easier for non-startups.
Yeah, but Azure's sweet spot is to copy whatever Amazon.
So Amazon hasn't done it yet. And Google is somewhere there in between. They just released the studio, but it's still nowhere. It's like, what are all the enterprise developers doing? It's unclear. It's still startups doing Python and hiding stuff in a mess behind the black box, and nothing that's still like a framework that you can use.
Get the idea. Yeah, just to, but I don't know if I'll put it on the screen.
Are we making progress or?
We're going to plan B.
Plan B, okay.
Screen sharing the Zoom.
Okay.
This is the way.
Like this.
This is a good time to visit the restroom.
Yeah, go to the restroom. Sorry about that, guys.
So now as I want to.
Yeah, well, I'll give you permission, Paul, if you'd like to come. Anybody over the age of 60 is allowed to visit the restroom.
Luis. Julian, can you put the Zoom into senior mode here?
Yep.
Sort of happen organically, I think.
We can switch to the.
You popped up over there. So.
Me playing around. It's not.
You were there.
Fix into it. That's
Could you? We've got 3 fixes in open source stuff.
Anyway.
Meet you in person.
Was that kind of asking?
Yeah, close enough.
Eventually.
Raised.
Well, the big concern is there are 8 guys that are
something.
Charlie's great.
Remember something is
Also connected to 2 of
just right that one
Charlie's.
Yeah, he's the
guy attention.
COE. He's writing code.
That's leading from the front now.
My favorite kind of guy.
Fresh eyes, analysis.
Reminds me of the energy that
Discipline.
Go.
Cool as a one time. I suppose. One played and I'm
waiting for my use cases.
What happens?
Same. Well,
So it's it's a dashboard. Whole thing. What it does is we call out the LLM on an it's pretty much I got you need to query my database to get the top
You're connected there, are you?
One of the things was we go
I watched RT6.
explain the but how do you it depends.
The dependencies are
so running on so close that it creates its own VM.
Because it's
with AI.
We met the bit. John, didn't you say?
I use personally.
Not counting. Trouble getting connected, so just a lot of chatter happening.
I mean, you get rats right.
Yes. I'm gonna do last week, so the basic AI session with them.
Yeah, I know.
I have a hyperscalers like they'll always go with that. I've seen it, especially
they were based in London. I don't know.
Yeah.
It's basically just killer. That's what
You got their abilities.
You're almost on top of yours.
There's no computers involved.
You spoke this. You spoke the larger address, aren't you?
Yeah, that's right. Kate Pattonay.
the LLM outside of.
She was the one who hosted
There are many data centers that exist in the web. So you.
It still is.
Everyone is dependent on where the data center is. Technically today.
Making of the.
Example for Saudi.
So you basically can't afford it.
That's where the problem is.
I'm going to go and try and find the AV.
There's 200 people.
It's up for
Yes, that's it.
Trying to figure it out.
It's still there.
I might join in with that conversation.
Back your Alex and How's it going, my friend?
Know that
Wait for which one is it?
Oh, yeah, we're just scratching the surface.
Today and tomorrow.
Oh, okay, so.
But I think that we can screen
Sorry.
Queer told me that people are showing
your contract.
2 minutes. I don't know if it's real. I don't know if you can actually
just let you know.
Let me know that.
Generate a movie.
No, you can't do that.
How I would do it. Then you know you're
Maybe generate 2-3 second video. One of the bro, see the next video with enabled. That's how I would do it.
Back.
It's not by 5. Cheers. I have at least 7 social media channels. They were consuming a million.
No, like the W guys.
And somebody from the team put in. Model coming.
Let's go and change it.
It's expensive out of ever still even.
Let yourself in there.
That's what happened. So that's yeah. And then when I met you, it's evolving stage.
Satya Nadella talking about AI replacing everybody.
Yeah. No, I think that's what everyone is.
Ready. Sorry about the AV problems. We are back. So there's been a lot of discussion during the day today about Morel, about the importance of business rules and the value that business rules have throughout these database systems in enterprises. So what we are working on at TNE is a piece of our overall system, which Rich will show more comprehensively shortly, called TNE Procedures. And TNE Procedures is about making the capture of business rules easy, making it almost passive. So that is, you'll see that we are doing it from a conversation and building business rules and
Guys,
and recommendations.
So you're not sharing it on Zoom. Could you log into Zoom and share the presentation as well?
Yeah. I'm only permitted to share desktop.
Should be permitted to share anything.
I agree.
We need a prediction from Rich Tong as to when this will change.
2072. There's no prediction change.
Okay, there we are.
Yeah.
And is it possible to just give like the overall, how do you position the TNE platform right now?
That is more of a Rich thing, the overall platform. Rich, do you want to set up?
I think we're trying to do something very simple, which is you've seen building these enterprise apps is really complicated, and there's a whole bottom half of it. You have a great team doing it. A lot of consultants and vertical people don't. So our mission is to work with retail vertical partners to build the bottom half of the AI, and they add the knowledge. So today we have 5 customers in different verticals, from government, retail, to manufacturing, who are basically building solutions on top of our stuff. And then we go to market it with a revenue share.
Is there different verticals that you're seeing this more applicable to? Because
I think, it's sort of the traditional thing. FinTech is obviously a big one because there's so much knowledge work. We see a lot in retail and particularly supply chain because of supply chain issues. We do see quite a bit in government as well because people are doing a lot of reports and things. And our first product is really a way to quickly write a report and recommendation. So you have to copy and paste everything.
So maybe I can just sort of go with color there because I am loosely associated with the T&E.
Loosely associated, Paul, you know what I'm doing.
What they're finding is the top Fortune 100, Microsoft and everyone else is all over them and is promising them the world and telling them that all they have to do is write a bigger check and they're going to solve their problems. When you drop down the next tier, where Microsoft doesn't have a direct sales force calling on them, and you talk to the CEO, they have no idea what to do. They don't do anything themselves. They typically work with a system integrator, advisor, partner. And the biggest issue that the CEO sees is how do they capture the current business logic that's in the head of his or her employees and make sure that the apps that are built and deployed exploit that business or both exploit and are constrained by that business logic. So if you can have a solution that not only allows them to develop applications more quickly, but those applications tap into currently informally stored business rules and logic. So if you can be combining business requirements and this big body of textual and soon to be speech-based information, which is in unstructured formats from which you have to extract business rules. And when you synthesize the application, you're synthesizing it in the context of both of those environments and produce a solution. And as Rich has previously told this group, you weren't here before, if you talk to CEOs, the biggest concern is, how do I get trained employees? My business logic in the world is held of 5 or 6 employees. They're in their 50s and their 60s. They're going to retire. What am I going to do then? So in that context, they've been building a system.
That is the best summary of what we're doing and what I've ever heard. Okay.
Just give me some more stock.
As much as you want.
So we're going to go through, I want to set up a scenario for you, and we'll go through steps of that, and then we'll see some software demo, and then we'll go through some more detailed steps. So here's an example of in the fashion business, Juan and Alice work together at a fashion company. Juan's manages handbags. Alice works for him, and Juan wants to trail slow-moving product to make room. And like a lot of companies in this business, they have basically unlimited data, but they do not know what to do with it. So is that on Zoom?
Sort of.
Dog. The ones we could probably be around that made around for you.
You've got a echoes problem there. Just tell us what it's saying.
Rock check.
Long story short, these two people are having a conversation, Juan and Alice, and our next step is to do a transcript of that conversation. So here we have the transcript. The text becomes a set of business rules and a recommendation description in our procedures component. So out of this conversation, we extract things like formulas and definitions. And also, because this particular conversation is task focused, it ends up with building a recommendation out of the data that they have. It extracts that as well. So this is the transcript of the conversation that Alice and Juan had. And I'll show you how we turn that into business rules and into a specific report. Okay. The first step is the conversion process, which I'm only going to show you. This is the procedures in our T&E studio. And this is processing the text. So that is the transcript into these goal, define and filter, analyze, and impact. So that's the components that were extracted, that were distilled from the conversation. And let's move over to make it happen. So this tool is procedures. So this is our first sort of test harness for this technology of extracting business rules and applying them in this practical way. So you can see a group of procedures over here, and then the model that we've built does the extraction from the conversation into the goal. We talk about it as being find and filter, so the top level filtering of the data. We tell and the analysis that needs to be done. So that's calculate rate of sale. So this has come in as just these two people chatting, and now it becomes not programming code, but it becomes pretty structured, pretty specific procedural description of what needs to happen in this report. So then the next step is to convert this to some code and then see the results. So let's see, what do I want to do here? Okay, I'll change this a bit. Let's say we want Financials, let's look only at crossbody bags. Here's analyze, and there we go. So that was converting that description. We've gone from text to structured text to business rules and a precise specification to code, and then we end up with that. So that is the speed of that. Then we do this description of impact analysis.
Let me just pause. Rich, is this the latest? That's all running locally?
Yeah.
So all of this is being done on what?
It could be. This is a 3.70.
Could be. Okay.
Yeah. This is Rich pointed out. Yeah.
Okay. This is a TV.
Well, no, just be clear. It's running on 32B. We just haven't run it locally.
Okay. It could be run locally.
It could be run locally. So
you could do this in your kitchen.
Yeah, so I want to just be clear about this. We've designed it so we run the models so they can be run locally. Sometimes we just run them in the cloud because it's quicker and cheaper, and they give us free access.
So next step is impact analysis. So this was extracted total cost at risk, the sum of the total inventory and the inventory cost for the 5 identified products. And then, so after those segments are generated, we can go to do the complete recommendation. So generate analysis, and here we go. Here's the complete report. This is both textual and the tabular information. This one is just the identifying information about selected products for being tailed, and then this is the complete product details. And this has the export to Office and Word and Excel, as Rich mentioned. And then we can go back, edit the procedure, and make changes. In that, so we could make it crossbody bags, we could make it handbags, whatever. So let's see, let's go back to slides.
And did you in some way now recognize that as a standing scenario that you can reapply? I mean,
yeah, that's the
idea.
That's coming up, but it's a fine point. So the design point of this is that we want the artifact that's produced to be not just the report, but to be the script that runs the report. This is Rich's idea about let's make stuff deterministic and cacheable as soon as possible. So I
mean, you don't want to start every one of these scenarios from 2 people having a random conversation.
Hello, Juan and Alice, I need you up here. Yeah. So the idea is it'll be a parameter to the report. What is the data source? So it might be the data source, and there is some stuff about building views on top of different data sources so that they can. So there's a little bit of portability among specific data sources as input to the generated report.
And this scenario came out of your work with retail customers, right?
That's right.
People who are selling fashion goods and other retail goods to the world.
That's right.
And you said you've got some other scenarios like government. Do you have any demos from them?
This is the one that I've built so far.
Okay. Yeah, so just asking.
Can I just clarify what I'm seeing? I mean, Beam AI, for example, allows me to capture the SME knowledge, as you rightly highlighted, which is a concern, and that generates the agentic workflow. So that's just capturing natural language, what somebody who's very tenured in an organization does, and turning that into a workflow output to then generate your agents off. Power BI allows me to interrogate large quantities of data through OpenAI, effectively running down the right-hand side. You're generating procedures. Have I understood all this correctly?
Yeah.
Okay.
Yeah, that's what we're doing. And another angle, as Paul pointed out, is that we have that idea to retain the generated code and reuse that. So it can be distributed, it can be edited.
So one of the, I guess, big questions I've been scratching my head about for the past 2 years now is, do we shift to a more consultative sales process for this type of capability, or is it more Beam AI product type?
Oh man, I mean, see, that is totally the crux of my, like, every time I sit and describe a product or think about coding, it is totally the tension of like, what is a very general model and what is like, exactly what Bob on the 33rd floor needs. So I think so my job is really to walk that balance between like what is what is specific enough to serve conveniently a lot of customers, and then we can.
I think about this, and it'd be interesting to know what you think. And this is just what I throw it is in some ways this will eventually replace and automate the way system integrator will go away. that you won't have to ask that question. Is this a consultative sell or say, because it will have a natural language personality to it up front that will allow the customer to first encounter this through natural language and say, this is what I am trying to do, this is what I'm trying to accomplish. The kind of things that he would have said to the system integrated consultant, who then would have gone off and produced the app to do that, will now be made directly to the system, who will then get the desired result coming into it.
So do you think the long-term direction of travel is completely touchless, or do you think there's an intermediate?
No, I think it's always, I think it moves in the direction of lessening the amount of intermediate touch needed.
Yeah.
So even though Rich, and I'll say this in private in this room, even though Rich's strategy right now is to work, which is the correct one, which is to work with vertical people with vertical knowledge, mainly because they have entree to the customers. They know those customers. They're trusted by those customers. They know, but in effect, at least in the certain aspect of their business, they're automating that away.
Yeah, but just to play devil's advocate in the short run, we're shifting behaviors, right? We're asking people to change the paradigm with which they interact. So at least in my experience in the companies I'm building, it's like, wow, you walk in and you have a different construct. I'm asking you to change your workflow. So in the short run, the consultative interface, so the guys that are making the most money right now outside of NVIDIA are, of course, the consultants. And so anyone that can come in and say, the CEO says, the business logic that's embedded in your people, I'm going to provide IP and personnel that help you in that guidance, where you then out the other end have that logic. I think the other thing that's really interesting is as all of us in this room understand, from client server to SaaS, there were huge business model disruptions. So am I buying a product? Am I buying an IP? Am I buying an outcome? Or am I buying personnel? So to the extent that it shifts to I'm pricing and packaging based on an outcome. And in the short run, one might argue that one of the key outcomes for everyone is, how do I take an IT organization and a data science organization and condition them to be able to consume this? Because I don't care whether you're a Microsoft shop or you're down market, the personnel in these organizations that are able to exploit this, the demo that Rich and you guys have shown, it's like, wow, there are a huge number. That is very valuable, just if people could understand how to operate 1/8 of it with 3 data analysts.
I think you need an army. I think you need an army of API engineers to be working 6 to 12 months ahead of what you think you want to do, because you'll get the first order very quickly with these products, which is great. And then you say, okay, I want to do something more. Then you haven't got the ability to reach into your.
And you're watching this with Microsoft with Copilot sales, and there are 200 solution architects in Guthrie's organization. They're getting clobbered. They can't do it.
Well, right, the API is faster now. Yeah, 100% agree. And nor can any corporate, in my opinion, unless you start now.
That's with the Paul's point. That's with the tip of the spear, which is the top 200 accounts that they actually have. Well, geography covered.
I don't think people realize that until they brought the product in and used it, and then they'll realize that they've got this massive backlog.
Just to speak on behalf of T&E, I think they've adopted a strategy that solves a little bit some of the dilemma that you're talking about, because they're starting to work. They're dealing with customers who have nobody with IQ in their IT organizations at all.
No piece.
So there's nobody.
Oh, by the way,
there's no resistance from the internal IT.
Well, the other thing is,
because there is no internal IT.
Make that point.
And they're instead working with their outsourced IT organization, which are system integrators, who can see what's coming, trying to get ahead of the curve.
But then it's sort of in the pricing and packaging model, who owns the IP?
That's
what am I actually
very interesting how that unfolds and develops, and whether you go from essentially paying on
am I buying
a usage model or an outcome model?
Right. Am I buying?
We're not nearly there yet, but there's a lot of mileage to be made by just going in and sharing the.
I agree with that.
Per user revenue model, which is what the guys currently use.
In the short run, I mean, to your point, like in the short run, to bootstrap the ownership of a procedure, if I can basically say, I'll go in and I'll deliver this for you, starting with I'm going to help skill your personnel.
Well, we should take this offline. I'll be here all day, but there's some very interesting challenges behind the T&E model to understand in the long run, where does your real IP result? Because as you heard with these questions we keep answering, right now, what a lot of their value added is in what they call the studio. That's their ensemble of things that they put together to enable you to deliver all of this. But one would expect that eventually the open source community will catch up with that. Right. All tools become commoditized. Right. So what can you retain out of that? And we shouldn't go into it now, but there's some really interesting questions there.
So the one thing, right, I see that everyone, whether if you look at vendors like Oracle, SAP, or Salesforce, everybody is doing it right now. Even Microsoft is building. Where you have to have advantages. It cannot be one database or one vendor database. It has to be multiple vendor database. That's how you can play an edge. Because what you just showed, SAP does it, Oracle does it, and even Salesforce does it. So what is the niche for you to make a difference? Because for them, it's easy to multiply the customer once they have a database. Or like, the synergy, they can use the synergy and they can do it. What you have to do it is, there is no access control today because anybody can run that query and they can pull that data out, which you don't want. Give it to everyone to have an access to the database, basically. So you need to have access to it. And where I see that if you look at one customer, there are multiple vendors who sits. And the advantage for you to have to do it is this query can hit whether SAP, Oracle, any vendors, then that's where your advantage will be. Whether you run on any hyperscalers, and if you connect to multiple vendors to get that data, that's a niche point. Because basically what you're doing is you're building a co-pilot for an enterprise. That's how I see it.
So to some extent, this goes back to the Pretender, which was the very first presentation we saw of the day, and that general pattern of almost a domain-specific data lakes for processes, and then kind of the orchestration and querying on top of it.
I think this interest of time, Paul, if you could open up the hood here and show us all the moving pieces underneath this would be good to see.
Well, there are two core parts three core parts to this system. One is the extraction component. So that is from conversation to rules and report structure. Then there is query construction. So taking the specifications that have been extracted and making those into SQL queries and prompts to the later stage model that does the text around it. And then just the pretty simple piece that does takes the previous parts of the pipeline and builds them into a nice.
So do you have a diagram here? Because can you bring one up? Because I know you guys have tantalized me with statements like that your latest systems have literally 50 different models running in cooperation with each other to enable this to all happen.
Hang on 1 second.
I was quizzing Dion on this last week, actually.
So Pitch is bringing up a diagram.
Bring up a diagram. Sorry.
Actually,
Are we going to get Alejandro?
Alejandro is scheduled for 6.
6 o'clock. Okay.
Okay.
Good time. Okay.
Same link, yeah. We want to bring earlier.
See if you're ready to go earlier. It'd be great. Good. I think everyone would appreciate getting done earlier rather than later.
It's feeling later and later now.
Index.
This just the index. So it's one no, I couldn't. It's completely disjointed.
All right, I'm just getting up the right.
So another way to slice it is that we can go from the simple thing to the things that currently cannot be built by composing these, which we should be able to do by being domain specific. So my hope is that we'll be able to,
well, I think
build agents.
That interesting if you just, without giving out their names, you've shown us the retail space here. Now, if I remember rightly, the government customers try to do something quite different.
Mm-hmm.
So why don't you just talk about what they're trying to do?
I might take over and show you that. God willing, that
The fact that they're building solutions using the same framework with people in quite different verticals.
Nothing like a presentation plan that just completely out the window. And part of it is I wanted to show that before we actually show the product set. So maybe can I just take 2 seconds to show us the product set and then we can show the different applications pool. So basically,
yeah, we can start our class.
So I just want to emphasize what I think we're doing. Do you need to do the Zoom share thing or are we good? I need to do Zoom share, right? Thanks. So Zoom share set here. Which one is that? I'm sorry.
It's in Senior Moments WhatsApp if that's available.
You get to see my whole life here.
Just a question for you. When you look at the commercials for some of this stuff, you know, you pay for request or pay for response when it's a cent or half a cent or whatever, and it's broken out so the response can be charged more if it's more expensive. When you start to scale this stuff, and like put something in the for loop, it starts to get really expensive really quickly. Have you given any thought to changing the complexity of your queries? So you're just putting one complex query in and getting one complex answer out? Because I think we're going to end up there pretty darn quick. Because I think what I'm seeing at the moment is lots of simple questions going in, and then all of a sudden you actually look at the cost of it and you walk away. And so I think the prompting and the idea that this needs to get very complicated very quickly so that what you're putting into the LLM is one hit to do all of that, rather than lots of hits to lots of LLMs, which I think where we're going to go in your architecture diagram. When I'm looking at this, I'm just thinking if I want to just condense that down to one request and make it really complicated, because you can do it if you're clever with the prompting, that will save you a lot of cost.
Surely it depends on your view of what that cost is. I mean, if you heard what they're saying, them trying to to the extent possible, go to local execution.
Yeah, I totally agree. I totally agree with that. By the way, I think that's the game changer in my mind.
In case your cost is zero. So
Oh yes, I get that. But at a corporate scale, though, they're not likely to deploy that for a long time for a whole heap of reasons around monitoring it, cyber, etc. So it's largely going to go to cloud in the first instance, in which case you've got the same problem. I agree on the endpoint. I think Apple called that right.
I agree with you. I think part of what we're doing is we're doing a lot more caching. I'm just going to show the way the system works. So what happens is, to address your point, we are trying to be that integration layer across multiple data sets. I think that's where you have to live because everyone in their silos got it. One of the key things is to basically cache just the data you need and just do one pull and operate on that. So
you've got the proxy cache of something like Not Diamond. Yeah. You've got your endpoint cache. If you've got 15 people in an organization not hitting the endpoint cache because it's got to go to cloud, your cost model is the same.
Yeah, and so the trick is to in the cloud put if you
caching all the way through. Yeah, I agree.
So that's what we're doing. We're trying to cache all the way through.
Boxes, yeah.
So proxy, basically at the data, and I'll just explain this. So our model is, and it's the tech model, is that at each level for this data, we actually end up building an agent that caches. Yeah, because it's the only way to do it. At your point, the idea is this means SAP and everything else. So this to us is the integration layer across all enterprise. And I'm a little distracted right now because I'm working on a customer thing, which is exactly, they've got files in Office, they've got a data set in SRP, actually SRP manufacturing, in their SRP order system, and they've got something in Salesforce. And what we're doing is we're basically caching the data and the agentic model here.
And are you able to go with my theory that you need to get more complex queries, much more complex to control that cost? Are you just caching the complex query in response or breaking it down?
No, Paul's built an amazing system that basically I don't know how much time we have, but there is actually a system where we take all the rules of the queries and then we have what's called a rule set relevance engine that basically says, here's what the relevant things are, make a guess for what we need to cache, cache that. And then the second thing we do is we cache the code that generated it. So if you need it again, you have to do the gen. So basically, some in our companies caches all the way down, right? Just keep caching and caching and caching.
Totally agree. Otherwise, yes.
Otherwise, it doesn't work. And that effect is I want to address Bill's point back there. Do you go broad or do you go deep into a workflow? To me, that's the big question, right? So we're making some early progress going to many different partners, but you sometimes wonder whether we should just go deep into one. But just to explain the way it works, so that's what all these models are doing, and they're specialized by industry. And at least right now, we're seeing there is some value to these specialized models. Like somebody that really understands retail, that doesn't understand retail. As we know, fintech is a huge category for commercial bank, all the way on. The second thing, and so this is the studio he's talking about, which we used to construct it. I'll show you in a second. There's a whole library of these things that we have. And then there's this kernel runtime that tries to orchestrate all this. And now, of course, all this will eventually be, when just like HTML5, it's all normal. It'll be wonderful, but it's going to take a long time. So we have to build these pieces. And then on the output side, we're discovering there's a large number of outputs people want too, right? People want memos, they want logging, they want multimedia. Some people even want automation, full automation all the way through. And so we're doing the same thing on the output side, which is to cache those things. And then the final piece of it is really thinking through what it means to have an AI first interface, like not too many buttons and doing everything through prompts and visual. That voice, that's actually quite hard to do unless you start at the beginning. So this is, in our view, is sort of the simplified integration layer that you were talking about, which is you've got all these silos of data, and essentially you have these three processes: finding and filtering, processing and analyze, and reporting and recommending. The piece that you saw, which you just pulled out, was how you can write all this stuff in English. So we actually have a way where we can copy PowerPoint presentations, write in English, but Paul's been pushing it even farther to say, well, can we just take a conversation and turn it into a set of rules? And ultimately, the real goal is, you have this quality cost trade-off problem of most people have to take quality and cost, and you end up with no flexibility. And so that's what this AI stuff is about, because it's really very fast program generation. If I were to go back all the way back. That's really all we've done is we generate programs much faster than it would before. So this is our first application. Sorry, I just showed you that other application. The application I'm about to show you is for one of our government partners. It has retail recommendations. You notice it uses exactly the same framework. It's actually the same data model. And this is Matthew Artsy. He did this in 10 days. He's never written a program in his life. He's just a business strategist. So I'm going to show you that in a second. What it's doing is it's taking normally a multi-page economic report that costs $200,000 or $300,000 and doing automatic generation of it.
What's the problem they were trying to solve? Which
The problem they're trying to solve is that, at least in the US, to get a federal grant, you need to you have to write a massive report to prove that this project is economically viable. So here are the net benefits, here are the reasons why. That typically is a $200,000 or $300,000 project that takes 90 to 180 days to generate. And what this guy would like to do, he's been an urban planner for decades, is turn that into a subscription business where if they have a prospective project, they can just see the report, generate it, and they don't have to go through this huge process. Also, particularly in the US, there are a lot of different constituencies. So sometimes you might have one talking about, urban renewal, another thing talking about this. And so they want to be able to repurpose these reports quickly. That's the basic problem that they're trying to solve. So I'm just going to. So this is our applications interface. I'm going to show you the studio interface in just a second. So just to explain this, so we put all of these applications into the same interface layer. So this is the one you saw before, and then we have a special portal that's just for the product. The company name is shall remain nameless, but it's codenamed Maria. So this is exactly the same model, except it's been converted. So you see as it populates, it's the same framework, but it's actually totally different data. So this is comparison of gross regional product per capita versus other places. This is the San Diego GRP analysis. This entire interface was hydrated by an AI. So we didn't write any TypeScript code, any of that stuff. It just fills in this new stuff. And you can see this actually has the format of a report. So they have section 1, section 2, section 3, and we have an agent that's an expert at each one of these.
What was the prompt that was fed to each of those agents?
The prompt consisted of, they have a bunch of specialized rules because they're econometric people that says, we want to compare the GRPs against the top other counties in the area. Yeah. We want to make sure that you all.
And are these web-based resources or are they databases?
No, they're actually categories. There's a corpus of this data this company has. To your point, they don't want to keep pulling. Yeah. We then cache it so the queries are all the same. Just so you know that, because they also want to be able to just query the thing. So this, for instance, was generated from a query, and you can see it actually has here's the gross regional product. It basically wrote the whole report for them. Here are the key insights, here are the suggestions. You can actually ask it questions.
And how do they hallucination check it?
First thing is that we have for these reports, we have a system that basically says this is the consistency check. Yeah. And you can actually see it right here down below. You see the system comments. This is our word for we call it the skeptic, but it basically goes through and says, here are all the reasons. In this case, there's sufficient data on growth rates. There's no industry-specific data, which tells you what the growth that drove. So this is sort of the real time. And then the second check is essentially this is actually code written in English, right? GRP for San Diego was calculated by something GRP is all industries, et cetera, et cetera. So it just basically gives you the back calculation.
But is that, do you have an agent that knows how to write a report?
Yeah, that's what this is.
So if the report needs to change, you need to tell it to change, or?
Right now you have to write the business rules to tell it to change. And with Paul's thing, hopefully we can just have a conversation and we can actually inject those.
So you have to write the table of contents effectively.
Effectively, yeah. So, these things are not smart enough just to know how to write a report. They have to be taught, which is sort of the behind the firewall data that's so valuable right now. By the way, the guy who did this said, this is going to completely change my business, right? And to your point, this is actually converting consulting into software. Because he has a consulting business, which actually kind of is a great business, but it's not a scalable business. And he'd like to charge, $1,000 per urban planner in America to just do this.
But the end users even know that it's AI doing it. Like,
That's the point.
he's not physically there. Then
No, in fact, we don't, we never use the term AI when we present this stuff. This is just the world's fastest report writer. Key learning for me is this AI thing is both the most wonderful thing and the most scary thing ever. Yes, sir.
So am I the only one to worry that if we use AI to automate crappy business processes, we're just going to end up with crappy business processes on a human scale, and we're just hurtling toward a void? I mean, I can't help but be scared when I see some of that stuff. Because a lot of the human business processes are totally broken, fucked up, have no reason to exist. We'd be better off without them, and we're just automating this. And so in some ways, I'm kind of worried same things that happen with software to some extent, where there's a lot of business rules that get introduced and stuff and so on that made no common sense, and we're just going to produce this on a scale.
Yeah, you could make, Eric, you could make that same criticism of the computing industry for the last 60 years, though.
I know, and to some extent it's been true, but I'm afraid we might reach the level where it becomes, we can't contain it anymore.
I think the other way of AI consultants come up with fixes, sell you solutions for it.
The other way to think about it is, if you look at each one of the transitions, the first thing that happened is we took and we just mimicked the past process with better tech. Right? And it was like, wow, there has to be. And then what happens is somebody comes along and says, all right, I'm going to reimagine this process. I'm using the word process, which is a lame word, but I'm going to reimagine this process with this more intelligent, capable software. Right. So you're right. If it's in this context, I totally agree, because all you're doing.
The interesting potential here, which I think is very speculative at this point in time, is one of the reasons why it's been hard to change processes in the past is the processes were completely informal, not written down, not well documented, despite all the efforts of the business BPML industry, etc., that never happened, never succeeded. Now, for the first time, you're getting systems that will be capturing business rules and process rules in a format that you can reason over.
So you think people will realize that a lot of
and this is where it gets very speculative. Where it gets very speculative. For the first time, you might have written down in a format that a system could reason over to actually say, here's a better way of doing it.
Okay.
And that's very speculative at this point in time, because you first have to get it into a format that a system can actually reason over it. And my hope for this, in addition to them making a lot of money in the short term, is that they will eventually end up with a body of rules that they've abstracted from a lot of industries that are in a format that we can now apply AI to actually reason over those and come up with better ways of doing things. But that's TBD.
Just one other data.
This is Wasif here. I think just the process of asking questions and writing the rules is also an opportunity for people to try to come up with something a little bit smarter, especially if they know that they don't have to be hard-coded to an output that takes, many years to implement and many, many millions of dollars to implement. So that cycle, hopefully, Eric, will mean that some sense will creep in.
I still want to. I want to see the guts of this thing, Rich. Get dirty here quickly.
Sorry, we got high level. There's no level. Okay, I'm going to do that.
I want to see those 50 LLMs.
You're going to see the 50 LLMs.
The connections.
You will see them. I just wanted, before we dive into that thing, just explain the products that we're trying to do, and then we'll dive in. So the thing you've been seeing is this thing we call persuasion. And I admit it's the smallest possible thing because it's the easy way to start. Just try to take data and turn it into compelling recommendations in Office. It's a very simple little thing. The second thing we're trying to do is we are working with a market research firm right now to build a product that actually looks at internal market research, internal trends, and tries to generate some of the patterns you see. Once you do these things, the third thing that we've heard a lot about is, okay, what are my KPIs across all these silos? How do I know really what's happening? This is my dream, is the email reader that tells me, actually, this meeting didn't happen and it was supposed to happen, right? But Paul, the punchline is once you do all this, you pretty much have most of the procedures inside a company. And so we hope to be able to reason on that. And so this is our ultimate, sort of picture where we'll end up, sort of observing the world, deciding, making decisions, performing, collecting procedures, and someday maybe we can even help on the back end, on the pipeline. Now I'm going to show the real stuff. Any questions? Okay, so
and I did at the risk of self-promotion here. One of the things I've been saying to Rich and team for a long time is the Gen AI in business right now, we're at the co-pilot stage. It's an assistant. It's something that just helps you figure out, particular interfaces or what you need. The real prize is to go beyond assistant to becoming the coach. To somebody who looks over your shoulders and says, yeah, you're doing the right thing, but you know what? There's a better way of doing this. And that's really where the pot of gold lies. But you've got to get there. You don't get there in one fell step.
Did you see in the NVIDIA keynote at CES last week, that was what Jensen was describing, like you'd spend a lot of money on your master model, but it plays a quality control role and a training role to a lot of cheaper, smaller models that are agentically doing a small task. That's the architecture they're going for, because the big ones are really expensive.
So this is the live system. So what you're seeing here is, just to explain this, so there's metadata. This is the retail example we just saw. So there's metadata about this, which is basically handbags. There's a bunch of domain rules, and then there's some syntax rules, and this goes into a relevance filter because there's so much data and so many rules, you can confuse the model. So if you say, I want this, it only extracts the relevant data and the relevant rules to basically feed in. And this has to do with the problems with context, because if you fed it 400,000 lines of rules, it wouldn't know where to go. And this is our, just to explain, since Paul wants me to explain the whole thing, I'll explain the whole thing. So the first thing that you actually get is you get a set of instructions on how to generate the code properly. So in Ollie, with this new world, this is the coding practice standards. So actually, it's awesome, right? You can actually have coding practice standards that someone follows. Then there's the rule syntax, which basically has to do with what is actually going on in the rule set. Then there's general rules that have to do with things like, you'll laugh, things like if you ask for a year, you should do 12 months of data, those kind of basic facts about the way things work. My favorite one is don't express units and fractional points, and all the things that I've spent many years of my life coding, just trying to fix these things. You can tell that. This is the same metadata, and this is the actual raw data run. Now, in this case, we didn't do a live SQL feed because this is a demo system, but there's something in front that caches this. So the idea is only the most relevant things. This goes into our first optimization, which is the code generator. So one of the tricks is that instead of processing all this data, we actually just run through a code gen phase. So it says, don't actually implement those rules. Give me a program that understands these rules. One interesting thing is you can say, make Rust, make Panda, make Python, make anything you want. So suddenly language standards, which bugaboo of IT, has become really easy. It's like whatever language you want, we'll just flip to it because these things know how to gen well. And you can see there's a bit of extra data here having this doing Python generation. This actually turns all this stuff into a simple data frame that can be read by the chat agent. And the reason for this is that large language models, ultimately, they just have a stream of text, right? They don't know anything about files and so forth. So we need to feed it just the right amount of stuff. So the code generator, in essence, is doing the find and filter and process it into a small number of summary tables. And so that goes into a little module that does the transformation. And then this is the chat agent. So we didn't have a chance to show the chat agent, but you can just talk to it. And this actually runs the chat.
So if I can comment there, by doing it this way, when you go like to CodeGen, at that point, you guys have selected the best model for generating Rust. Yeah. So, depending what you do there, you're going to pull in the smallest, best trade-off model to do that one particular task.
Right. That's right. So, so for instance, just to talk about this, so that particular model we're using, the flavor of the month today is Quen 2.5 32B coder tuned. That is today the best model. I'm sure in 2 weeks, Paul's going to tell me we need to use DeepSeek V3 FUBAR, and then we'll do better. So that's part of the shim that you have to do.
But that's not on the only dimension that you have variability, right? You have
Yes, it's subject to cost, size, deployment model,
accuracy,
etc.
This is our meaning of the word agent, by the way. It's agent with a small a. It just makes something really specialized that generates tight code that can run on a local system. And the chat model is actually quite different, right? The chat model tuning, as we saw with the theme thing, is a completely different tuning. Be verbose, be cheerful, be happy, all those things that people like. So that's why we feed the exact same data. This is largely the same data, but the model is completely different. So if you look up here, by the way, it's interesting. It gets a copy of the generated code. So when the chat is there, it actually knows the code that it's running. So that's how we, for instance, do here's how the data was done. Here's how we derive the data. So it can just read the code to see what it is. And it gets the same syntax rules, it gets the same domain rules, it gets the same metadata. You notice it's not getting the raw data, right? Because that's coming in summarized form, and it gets the general rules like, be nice, don't talk about Hitler, don't do any of those bad things.
Which is in the code generation, are you just out of the box working like there, that code doesn't hallucinate, doesn't produce?
Yeah, so what happens is that in the code generation phase, we then run it and actually you've worked on this project, but we then verify that it's actually working, and if it works, then we cache it and we keep it forever. So we have a judging model.
How? You verified how? I mean, I know.
So there's two ways that we do it. First is we tell the user that we're running this code and they inspect it. We also run an LLM jury to say, is this code functioning properly? So we do both.
Well, yeah, but functioning properly, it's different than hallucinating, right? In terms of code.
Well, many times. So usually what happens.
No. 10 minutes.
So usually what we have to do is, this is where the yes and no comes in for users. They have to look at the actual output to see whether it's proper. But you can also do, more linting-like things, like could this code actually function? Does it actually work? And so you have to do both those things at the same time.
I've also found with code that because the cloud providers don't want to be recursive in generating you the best code, they let you come out with a first version, and if you cut and paste it and send it through 3 times. So the endpoint version lets you do that. But for your code, are you running that several times to get the best code, or just getting enough code, which is the point down the end of the table?
So this is a good question. So right now, the current system just does once through. There's a bunch of new models called QW. There's a bunch of models that actually will run multiple times. I didn't get to do the rest of my presentation, but basically, there's no time. But basically, there's sort of the one-shot thing. Then there is running it multiple times, and then there's true planning agents that will actually go through multiple things and decide what the best one is. Right now, we're just going from one shot to a real more planning-oriented, more like O1, right? It's called Marco, but doing that. And I think the next step will be it'll just run over and over and over and over and over again and improve. I will comment that most of these queries are simple enough that you don't have to do this. If you actually read the code, it's not really super complicated. And it makes sense because a lot of the data transformations are pretty, you're not doing like 72 joins, basically, you may do 1. So that's the top level. And then what happens is, I could spend a lot of time on this if you want, Paul. So this particular model is actually made up of, well, actually, this is a good time. So we have actually, this one first ran against ChatGPT. This one runs against Llama. This runs against Llama 70B, because you have to do certain tunings as you go down. So this is basically the Quen model, et cetera, et cetera. So although everyone says, oh, it's just so easy to do the prompting, we're actually finding there's a lot of value in just doing the hard work to make these things run. And I'm proud to say Paul has gotten this model running very well. So this runs at fully 32 billion parameters with a 7 billion parameter front end, which we can run locally. So there's this iterative process of start high, and then you keep working your way down. You learn what's working, and between the small models improving and us getting more concise, that's actually working.
In the short term, I think that's some of the value added that T&E has that the system integrator won't have. So they can save the system integrator all of that effort of having to figure out what does and doesn't work and what to choose here, etc. And as Rich said, I mean, they had some examples now where somebody with domain expertise, with no programming experience, was able to put together a solution in a small number of weeks without having to learn anything about Python or etc.
And I told Julian we thought we could go more broad in a couple months, and I'm thinking more like a couple weeks. So because this just happened and it worked so well, this was very encouraging because the previous system took 90 days to do, and he did this in 10. And so we feel like we're getting closer. And then with Paul's innovations, with just reading, listening to random things, it could actually be we moving from a system to coach more quickly than we think. Because if we can just do an interview and get these rules out, then we've really accelerated a lot of things.
There are companies selling something like that as their entire objective. That's their business. That report writing framework with AI, that is their business.
Yeah,
I am doing it as a spin-off of the past.
There's everyone with every business model right now. It feels like such the Wild West. And I guess I would say we're just motoring ahead because we're finding that, particularly in the more deeper verticals, there's just so much demand for just make this simple, just get it out. And let's just do this integration layer and make it work. So I guess we're charging ahead. There's a lot of ways to make money. I'm very enthralled with we can be part of the business process saving thing as opposed to just being a cost item. And that to me is the big.
The other thing, Rich, maybe we need to wrap this up and let Andre get in here. But the thing that I think you guys have done well is to the extent possible under the hood, the system is described declaratively. So there's a minimum amount of Python plumbing that's going on here. Their whole system gets essentially driven and put together by a set of, YAML files or whatever it is that basically, so reconfiguring, bringing new components in, etc., is essentially somebody who understands the YAML files can essentially configure their system. Which I think, at the end of the day will be an attribute of whatever.
Oh, it has to be.
Whatever evolves as the framework for this space.
I wanted to show you this since you're talking about this. So this is a code fragment from LangChain in terms of how you do it, right? And so this is our code fragment. And you can actually sort of read it, right? Smart home expert, here's the prompt, write this thing, make this event, make this happen. Here's the string. And so much of the stuff is just basically a bunch of strings and a bunch of calls. And so what we're doing is we're choosing to build a system that just uses YAML files as input. So all of that stuff that you saw in that studio, that's just a big YAML, that's just a big manifest file. Right?
But that's really, when you create the code, you have a snapshot, you have a bunch of applets. How do you even orchestrate between all of them? If somebody wants to change the report generator to add 3 more repositories, you need to change the code, right? How do you version it? How do you?
Yeah, no, this is all version control. So just so you know, our entire system is all Git-backed.
Okay.
Everything's Git-backed, it's running locally. So that's how we manage control. It turns out it's also much easier to reason over YAML files than it is over Python. So we actually, the linters are like 1,000 times easier because you just cut all of the gunk out and you can't have a missing semicolon, or in Python, the double spaces instead of the single space. And now the if is in the wrong place. Because it's one of those wonderful space sensitive languages. Oh my God, who invented this thing? So I think this is one of the key things that we're focused on, which is just this, everything should be just a static file. And then we can inspect it and run it.
That's also RL why we're not using Python and why we can't use LangChain, because then we have to change a lot of code every time we change this. And this is Satoshi's brilliance in building this GraphI scheduler. You only write rules in English like that. And that's the only part you need to change. The framework basically follows that as the inputs. There's no code change.
Good. I think we'll open up Alejandro next. So any final
Very much
questions
for
for
your
Rich?
William.
Rich is a. I want to thank you for reading those 10,000 papers every month.
Yeah.
A lot of those papers.
Anyone online wants to follow up afterwards, just drop us an email and you'll get put in touch with the lovely T&E guys.
Have it recorded?
Yes. We're not going to record Alejandro's though. So I'm going to switch off recording now.